Kun Aerospace is a AS 9100 Review D, ISO 14001, 9001 certified company. Panel number 2 is Mr. S.M. Vaidya, Executive Vice President, Godrej and Boyce Aerospace. He is a metallurgist from IIT Powai 1983 batch. Worked in Autoclean L&T before joining Godrej in 87, and he has acquired expertise in welding. And he has acquired certifications like AS 9100, ISO 14001, OHSAS, NADCAP, and ISO 27001. He's been awarded by the AESI for development of cryo engine technology. Under his leadership, Godrej Aerospace has received several accolades. Mr. Vaidya operates out of Thane, Bombay. He is a member of Senate of IIT Bombay. We are very happy to have you, Mr. S.M. Vaidya. Welcome. I am moving on to panel number 3, Mr. Dipyendu Maiti, Executive Director, Corporate Planning, HAL Corporate Office. Mr. Maiti is a postgraduate in Aircraft Production Engineering from IIT Madras and MS in Aeronautics and Space Technology from SUP Aero, Toulouse, France. He has done Leadership Development Program through IIM Ahmedabad and is also certified PMP, Project Management Professional from PMI USA. He has led various projects including setting up of facilities for repair and overhaul of Su-30MKI aircraft. The Su-30 MKI ROH in the world has been produced in this plant, the very first Su-30 MKI ROH. He is presently working as Executive Director, Corporate Planning. Recently, various strategic planning activities have been initiated by him, mainly focusing on business expansion and performance improvement. Panel number 4, panel member number 4, Mr. P.S. Ramesh, Executive Director, Dynamatic Technologies. Mr. Ramesh is the Chief Operating Officer of Dynamatic Hydraulics and Dynamatic Old and Aerospace India. He is now heading the group technical services and HR activities of the entire group. His career in aerospace industry spans over 3.5 decades. He started off his career in HAL in 1982 and was associated with production of Jaguar and LCA, light combat aircrafts. He served abroad for 5 years as Head of Quality and Technical Services Manager in SMEA, state-owned Malaysian aircraft industry. He is a Six Sigma Black Belt and ISO 9000 lead auditor, and he's been trained by FAA on Aircraft Certification System and Evaluation Program. He co-chairs, Mr. Ramesh, co-chairs the Aviation Expert Committee of BCIC in Bangalore for 2019-20. And he currently serves as a member of the CII Space Committee and CII R&D Committee. Welcome, panelist and moderator. Over to Dr. Palta.
Everybody, we are going to have a look how we need to rejuvenate the Indian aerospace manufacturing in the post-COVID area. We all know that the aerospace sector is under severe impact of the coronavirus pandemic since a year now. Never before in the history of aviation, one has witnessed so on the airports all around the world. The aviation in early part of 2020 had almost to a standstill. And it is only limber from that situation. The deliveries of the airlines, consequently, in the year 2020, dwindled substantially. For example, Airbus had cut down the deliveries by 34%. And in the case of Boeing, the impact was more severe, compounded by the 737 MAX problem, down by 59%. The consequence impact on the entire supply chain of the aircraft manufacturer worldwide was very severe. On the domestic side, HAL is the major aircraft manufacturer. It had been waiting for the LCA order of 83 aircraft since quite some times, which has been released only this year, means in this month. ALH, the Dhruv helicopter, very successful HAL program, has had success. It has produced a number of copies, but today, even in that program, the numbers are not very large. The next program of light combat helicopter is waiting for order. The light utility helicopter does not seem to still have picked up the attention and encouragement that is due to it. The only production programs are DO-22 today in HAL. Come out of the impact and they are taking it forward and discuss what on a macro level for the aerospace manufacturing industry needs to be done. I would make a start with my friend Surendra Vaidya, Executive Vice President, Godrej Aerospace and Defense. Surendra, I would request you to first lay out the total situation in the Indian aerospace manufacturing post the COVID pandemic. Surendra.
Yeah. Thank you, Dr. Naresh. I think you have given us a very good start to this particular dialogue, what we are going to have. I think before 2019, all of us were scouting and trying to get into more orders. And at the same time, both Airbus, Boeing, the examples what you gave, they were growing and trying to increase their production by at least 50% more than what they were producing in 2018. And at the same time, we were also looking for programs like LCA, ALH, and a lot of things coming from Indian space program also. Suddenly, in the last February, we had impact of COVID. And as you rightly said, the production volumes have come down drastically. Now, as all of us, we know that in India, we are basically into more of manufacturing of components, structures, and smaller subsystems. We are not into the final assemblies. And unfortunately, so far in civil aviation, we don't have a product of our own in India. So we are dependent on Airbus, Boeing as the two major OEMs in this aviation industry, followed by the engine manufacturers, because that's also another important commodity what Airbus and Boeing buys. And then we have a lot of LRUs and other subsystems which are going interiors, exteriors of the aircraft. So we were all suppliers of components, and you all know that the components are, even though we are trying to go like auto industry just in time, it is actually not happening just in time in aerospace. Everyone is trying to have a stock. Either you are supposed to stock it as a manufacturer, or the customer himself tries to keep a stock of minimum level so that in emergency it can be used. Replacement of parts from another industry is not that easy. And knowingly this, I think the Indian manufacturers, if I have the correct data, in 2019 and 2020, we added more than 400 machining centers in aerospace field, 5,000 employees. I'm just giving these bare minimum numbers. There could be many others who are indirectly supporting into this in terms of tools, jigs, fixtures, and other components. But even if we take this is amounting to more than something like 400 direct hours, 400 crores of direct hours which are coming. And now if suddenly we are going to see in this MSME and large houses, this kind of reduction which is going to happen, then it is going to create a severe issues for us. First, there is a skill or the qualifications which are mandatory in these areas, which are now going to have serious issues. If we don't have a continuity of more than 6 months or something like that, many of our qualifications will go away. We have important certifications like NADCAP, and those certifications, if we don't maintain with proper production orders, once again, requalification is going to become costly and very important. Third, getting NADCAP surveyors today in this pandemic is not that easy. So a lot of virtual audits are happening, and virtual audits has its own challenges. But at the same time, I mean, even though this is all discouraging things are not really good for a manufacturing industry, but at the same time, I think at this part of a moment, the government of India has taken really a lot of good initiatives like Atmanirbhar, banning 101 items, and giving us kind of an impetus to really look back and see how do we redeploy or have a good product mix between the civil aviation and the military aviation. So I think this combination is really going to get us to the next era, what we are really looking for after the post-pandemic. And what I have seen and what we are also doing at both pages, we are really taking up a lot of developmental areas, what we couldn't do when we were in full production mode, and trying to focus on that. We are focusing on what technologies we should really look into, and we are concentrating on those technologies, even though it's a difficult time. But this is a time we thought that good for investment and really creating some niche areas and really exploit the large workforce what we have to train them into the industry 4.0 or automation or digitization, so that as the volumes will pick up, we will not have many issues what we faced in 2018-19 when the volumes were going up in multiplying it and self-certification of it. So that's what in short we have a limited time, so I will stop it here and once again go back to you, Dr. Naresh.
Thank you, Surendra. I think you have painted a very vivid picture of what the scenario is in general, and also the Godrej experience and what steps are being taken. That's very useful input. Now I would move on to Divendu. HAL, we all know, is at the forefront of aerospace manufacture, and over the last few decades, HAL has created an excellent industrial ecosystem. So, I would request you to tell us what should be the roadmap going forward for the industry at large to recover out of this impact, what Mr. Vaidya had narrated. Divyendu.
Yes, thank you, sir. Good afternoon to one and all. The year bygone posed immense difficulties and enormous challenges globally. And while we come to terms with the new norms of life and continue doing business as usual, it's highly important to review, reset, and relearn the rules of the game to ace the pace or even fall back on track. This needs deliberations and involvement at every level, and in this context, AIDT and SAEINDIA have taken up a commendable initiative by organizing this event. And I'm extremely thankful to them for giving me this opportunity to be with the August participants today. Before going to the topic, let me briefly introduce my company, Hindustan Aeronautics Limited, or in short, HAL. HAL is an Navratna DPSU having turnover over 21,000 crore, 20 production units, 10 R&D centers across the country. In our journey of more than 8 decades, we have produced around 4,200 aircraft, out of which 70 types are of indigenous design and 14 types are through TOT. We have also produced more than 5,200 engines, carried out over 11,500 overhauls of aircraft, and 34,500 overhauls of engines. HAL has put our country in the global map with capabilities in design, development, maintenance of rotary wing platforms like ALH, Advanced Light Helicopter, Light Combat Helicopter, Light Utility Helicopter. HAL supply chain consists of more than 7,000 business partners, including around 2,000 MSMEs. Without whose support, we could not have succeeded in our journey. Now, coming to our topic for the day, one thing which is the pandemic has brought forth loud and clear is that we need to look inside for solutions, which will be long lasting. Now, taking into cognizance this important fact, the Atmanirbhar Bharat policy formulation has been brought forth by the government to extend the most needed support for the industry. First and foremost, growth of the manufacturing segment needs more order inflows. Towards this, in the defense aerospace segment, there is a huge need for modernization from the Indian defense services due to the aging fleet and collusive threats from beyond the borders. Also, the Atmanirbhar Bharat policy is giving significant impetus to self-reliance and local production. As part of this policy, government has announced a slew of reforms like negative list of imports. The first list of 101 items has been released, in which 4 platforms of HAL have been included. The next is reduced MRO tax structure, focus on indigenization of expensive imported spares, increasing FDI limit from 49% to 74% under automatic route, separate capital budget allocation to services to procure indigenous weapons and platforms, etc. Further, global tenders have been disallowed in government procurement up to 200 crore as a step towards self-reliant India. Now, further, once the foreign OEMs are aware of an item being part of the negative list, is forced to enter into arrangements for TOT, facility setup, etc. in the country, if the product has to be considered in the Indian market. The increase in FDI limit will motivate the OEM to enter into agreements without the fear of change in ownership of control stakes and associated compromise on IPR protection, security, etc. This again supports the industry ecosystem development in the country. In aerospace industry, the product support spans 3 to 4, even 5 decades. And during this period, we permanently become captive customers of the foreign OEMs. Hence, thrust has been imposed on indigenization of high-value maintenance spares, which will make us actually self-reliant. Make-to policy is also a promising development for the Indian aerospace manufacturing, where there is assured order availability upon successful competitive development. Hence, the industry has the promise for orders provided we are ready to deliver competitive technological solutions. So orders are available, but the users are looking for not just solutions, but competitive solutions which give them an edge over the adversaries. Now here comes the challenge. Aerospace segment is a highly technology intensive with long gestation periods. Technology are also fast changing, especially in the avionics area. Hence, the indigenous industry need to synergize and seamlessly collaborate, not compete, and building on the strengths and capabilities of each other. Here, the umbrella organizations like HAL can take the lead role while supported by a tiered supply chain partners, including the MSMEs and startups. This will ensure optimal utilization of the agility, speed of the smaller firms, and the technical expertise, maturity, long-term availability of bigger firms, as well as utilization of the already established capacity completely in the country. Another important requirement is availability of skilled manpower. We should look into academic institutes to have tailor-made courses which bring out talent who are industry ready. Academia also should reach to industry to bring out solutions to implementation difficulties faced by the industries in all segments. Now coming specifically to the civil aviation segment, this is the most hit business segment due to the pandemic. So here the government has come out with convergence of the civil and defense MRO segments as well as reduced tax structure, which are welcome moves to increase our order book. We need to look into all available capabilities across the country and offer our solutions to ensure effective utilization of all available capacities for the benefit of everybody. HL ultimately intends to be a platform integrator supported by a tiered vendor base of capable manufacturers. The Atmanirbhar Abhiyan supporting the indigenous industry will be a boost to these vendor development initiatives and will go a long way in retaining the skills developed in HL and Indian private partners while gainfully utilizing the experienced manpower and protecting the manufacturing ecosystem in this pandemic. Thus, the mantra will be collaborate and synergize. I'll stop here. Give it back to Dr. Patra.
Thank you, Devendra. That was, I think, very elaborate. You have not only recounted what are the measures taken by the government for the to encourage the industry, but also how HAL can be an umbrella organization, which it has been doing to a large extent. I think that's very heartening to hear, and the various measures by the government. And I think the mantra of collaboration is something, a very strong message. Now, I would like to take up with Ramesh. Ramesh, your organization, Dynamatics, in various interactions with the senior leadership of your company, we have heard of the success stories, how you have overcome the challenges of this pandemic situation. So I think it will be good for us to hear from you, for the entire audience today, to understand what are the various measures taken, what are the best practices your organization has followed, which has become a successful case study.
Thank you, Naresh. First is Dynamatics is a private company. Okay. cannot be compared with HAL in strength or the vastness. And the challenges were we have been supplying to big OEMs like Boeing, Airbus, and Bell Helicopters, apart from HAL. And for all four, we are a single source. That's where the challenge was lying. When the pandemic was declared, there was no way we could have told the customer that, yes, sorry, there's a lockdown in India, we can't supply. Because we were under the agreement, we have to supply. That's where the big challenge came to us. Apart from that, we were in 4 different manufacturing locations, 2 in India and 2 in UK. We had to do the proper coordination, get the materials, do the manufacturing, assemble them, and dispatch it to the respective places, 2 in US and 1 in UK, 1 in Europe. The Boeing, we send it to Philly and Seattle, and for the Airbus, we used to send it to the Bremen. Apart from that, we are depending on many small tier 2, tier 3, who are also badly affected, and some of them, in fact, had lockdown, had closed the shop. So at this juncture, we had no other option but to run the factory. And when April 6th we restarted, 23rd March was the closing, and we made all the homework and the preparations. And April 6th, our real production restarted. And perhaps we were the only company in Pune at that time to run the show. And we had difficulties. Round the clock, we had to run 3 shifts because we had the special process in-house. So these were the challenges we went through. And apart from that, there was no transportation and there was no canteen facilities. At 800 workmen, that's where the real Atmanirbharata, we started practicing it. Our own people started working in the canteen as well as the transportation, and made sure that with 50% manpower, we could deliver or meet the orders what customers were expecting. This is something we were reinventing ourselves, and we learned a lot how to manage. Meanwhile, it was very important for us to make sure that our workforce will not fall sick and the key person will not be available for the work. Hence, we started doing 100% RT-PCR testing on every worker. And there was a HR rule that no one can walk in unless he has been tested. And for any reason, if he's on leave for 2 days or 3 days, again, he has to go through the check and then only he can enter. The point here is we wanted to make sure the bigger group protected and the work will never ever suffer. I mean, this is something which we learned. And finally, we established our own RT-PCR lab with ICMR approval and NABL certification. And now it's running full-fledged. Every week, workers will undergo the testing. The point here is how flexible one can be when the challenges really confront. And that's a key to success. With this, definitely, we have been able to meet the customer's requirement. We did not face any big problems. But yes, a lot of work we had to do. And with that, we have been really gained more confidence or ready to face such bigger challenges. And we are ready for anything. That's what is the biggest of what we have found in our own team. The flexibility, trying to reinvent ourselves, coping with the crisis, and ensuring that customers are always happy. That has been our finding. Reskilling, we have done it. And probably what else, I can come back and I will go back to Dr. Naresh. But
thank you, Ramesh. I think this is one of the examples many of the industry can emulate. Particularly, I pick up the focus on Atmanirbharta, not just towards delivery of your product and services to the customers and the nation, but also Atmanirbharta in terms of running your organization in such a difficult time, which is the challenge which all of us have faced during this period and still continue to have those challenges. So I think these are very good lessons for the industry around. And you have also mentioned that instead of dwelling upon and waiting for somebody else, the government or the external environment to give a direction, Dynamatics did a pre-preparation and prepared itself to organize so that as soon as the permissions were available, it was able to get back into the operations.
You're
So
right.
the word you used was reinventing your own organization and your own strength. Now, while we have talked about Atmanirbharta of the organization, reinventing ourselves, still there are many areas where there is a dependence on the government, like HAL Executive Director had mentioned about the various measures by the government. So when we come to now, Srinivas Rao, on aerospace, you are present in a 100% export-oriented zone. And so I think maybe to some extent more than some of us, you are dealing with the government requirements and compliances. Notwithstanding that, I think taking from that experience, if you can say as to what kind of support is needed, because while we are using the word post-COVID pandemic, it's still not post. We are still in the thick of it. Fortunately, our country is better off, but rest of the world is suffering, and that as a global economy, it impacts us. So what is it that the government support is needed, whether at the central level or at the state levels?
Yes, sir. Good afternoon, everybody. So, if we see that even before pandemic, if you look at it, this for aerospace industry, the kind of benefits we enjoy from the government, I don't see much because we are EOU, of course, we don't pay any duties or something, and we get the raw materials. We need to give the account of it. But if you see, the government, what I expect from the government is, because for aerospace industry, we are largely dependent on importing all the materials. If you see a raw material EMS grade, you won't get anything in India. So we are largely depending on importing the raw materials as well as the all your hardware, because you don't have merely very few companies are approved to use the hardware. Like everything we need import it. So what happens is we'll have big burden of buying every time minimum 3 to 4 months material, keep it in your warehouse, where you have another problem is like you cannot keep the raw material once you buy it more than 6 months. Again, the customs implications will come. You need to reinform them and extend the bond. So we have a lot of bureaucracy related issues. So even when we are talking about our raw material dealers to have the bonded warehouses and store the materials, so for them also there is a big problem if the material what they bring it, if they cannot sell it off within the stipulated time, the government will penalize them of charging a huge penalty and the duties. I feel this way aerospace industry, there's no kind of support from the government. I feel government has to support and encourage, say for example, raw material dealers who are all coming forward to have the bonded warehouses. They should be allowed, if once they buy, because they buy raw material in a large scale, there's based on our requirements. For example, if you see the pandemic, because the pandemic, whatever the schedules would have been given to your dealers, all are getting postponed. Like so much of postponement happen nowadays because of the aero industry struggling. So they'll be under pressure. Like within the stipulated time, they don't sell the material to disperse the material. They will be asked to pay the penalty or thing. I feel some professional bodies like things they should put the representation to the government. They should support these dealers or aerospace industries should be supported in giving some kind of extensions and some relaxations. what I expect. And one more thing, what I expect from the either professional bodies and the government, we need to create we need to encourage the people who can come forward to keep these aerospace hardware. They can bring it and keep it without duty, so that we'll be more competitive in the market if you compare to other countries. If you compare with other countries like Vietnam, or like any Taiwan, Malaysia, hardly I think will be very expensive once with the international market. So I think we need to really look into that to safeguard our Indian aerospace industry. The government has to re-look into it. Maybe some of our professional bodies have to put the representations to the government, bring it to the customs. What kind of support we really in the Indian aerospace industry is looking for? We all know that we don't have any AMS grade approved materials from Indian mills. We are really struggling. Maybe it might take some more time to come to that level. As of now, we are really struggling. And even though if you see, we just started around 11 years back, and we came up very rapidly. Every year we have grown by 35%, and now we are approved by a lot of Boeing and Airbus software companies across US, Europe, and UK. We really struggle on handling this particular aspects. And like we have a lot of norms. Like in aerospace industry, one more thing is your raw material input to output ratio is the scrap what you generate, the scrap you generate is more than 80%, 90%. We need to declarations, and like so many government related documentations are really troublesome. I think we need to really look into this kind of things, or to ease and make it a very friendly atmosphere to the aerospace industry. I think I request the thing. And one more thing, if you see the kind of benefit or the things we got from the government during this pandemic, I literally did not see anything. What the government has offered for the aerospace industry, maybe we experienced that some kind of working capital. They give some kind of approvals to sustain, but other than that, there's no benefit I experienced in this during the pandemic from the government. The Atmanirbhar, okay, we are working with different sectors to put that slow, but it will take some more time to put a platform and go ahead. I feel certainly we should look into these directions. Maybe our panel members also can join in doing, and we all can work together in putting as a representation to the government. It certainly will strengthen our industry. It will be back on the track. I think with that, I want to hand over to Palta sir.
Thank you, Srinivas. It was very useful. You brought some good points, and I think what you mentioned that we should make a representation. Offline, we'll discuss with the SAEINDIA leadership, and otherwise we are all involved with other forums also.
Yeah.
So please collate all of these with specific recommendations. It will be very useful. Like particularly, all of us are facing this accountability of the materials. If I remember my earlier days, even in Excel, we had to go and explain this input-output ratio. I don't know whether that challenge still continues. So like that, there are many of these regulatory aspects and the lack of government support. So it could help. And this is the right time because government is now collating inputs. The budget is just 10 days away. So if we can do that, I think it will help ourselves. So that will be another Atmanirbharta step from our side. Now, so you have brought out the challenges. Surendraji, you had mentioned about, what are the steps at Godrej you have taken, preparing, training the people, skilling them, so that once the positive challenge comes that the work volume start picking up, you are ready for that. But on the other side, you also would be facing a lot of industrial challenges. Would you like to say what are the challenges you have faced or what you think the industry could face over next 1 or 2 years if preemptive actions are not taken by the industry? Surendra.
So, Dr. Naresh, I mean, it's a very important question, I think, for all of us, and especially at Godrej, what we have done is, one is really looked this entire aerospace business into two ways. One is that whether we have a right product mix. And in product mix, if you really see the three verticals in which the aerospace industry is really getting divided. One is the civil aviation, the second one is the military, and it has also the military missiles and bombs and other factors in which it can be served. And the third is the space. So we have fortunately balanced ourselves, and we are not really focused into any one particular sector. We are doing almost equally well into all the three sectors. Now, fortunate to us, even though the civil aviation market has gone down drastically, the Indian missile systems as well as the defense system has picked up, and we are able to do the fungibility between the operators and some of the machines in the two manufacturing plants. So that is first. However, it is not going to substitute everything in that. So then, as I said in the first, that the industry 4.0, digitization, automation. But one of the biggest lacuna, at least in Godrej, even though we have our own tool room, when I have visited many of the facilities in the aerospace sector, whether it is civil or whether it is defense or military, in Western countries, especially the developed countries and some of the Southeast Asian countries which are coming up, I think they have given a tremendous impetus and focus onto the tools, jigs, fixtures, gauges, templates, and they're very effectively using them rather than using only the machine capabilities. I think the machine capabilities are getting these additional benefits of these tools, jigs, fixtures, and gauges and templates. So we focused in the last 4 months in the well period and have developed more than 4,000. It's really a mind-boggling figure, but we really work very hard and develop those 4,000 tools and fixtures. And this is going to help us in the coming days as the volumes will increase. In first, de-skilling of the job. Everywhere you don't require a skilled person. And once you are able to de-skill, the multi-skilling will become effective. Because even though we have some kind of a line production, but balancing all the sectors or all the departments in this aerospace industry is many times difficult. And then you have in a particular week of a month, that particular section gets overloaded. The other two sections are not having sufficient workload. So how do we really move people? You may be having equipments, you may be having machines, but you cannot keep on adding operators. Finally, the fixed cost is also important. And in today's world, when the cash flow has impacted drastically, the reduction in fixed cost or appropriating properly the fixed cost is going to be the most important. And these two initiatives of de-skilling and multi-skilling, along with the assistance by the tools, jigs, fixture, I think will help us in tremendously helping us improving our productivity. Otherwise, our labor arbitrage may be advantageous to us, but at the same time, we are probably not due to having a good productivity. So that is the first thing what we did. The second thing what we also embarked onto is that we found that our interaction with academia was not that very effective. So we really carved out a small team. And in this period, when even the professors don't have the sufficient load because not many universities are having students there. So this is a time where we actually interacted with them and found out basic fundamental principles of this manufacturing as well as the different alloys and metals what we are using and understood their characteristics in more details so that henceforth any new process we'll be able to select. I think we have a better understanding of materials as well as the processes. The third area that I think everybody is going towards lightweighting or towards everything making as lighter as possible. So we have really focused on to various aluminum grades and how those grades can be formed, work, and the techniques like impulse forming and hydroforming and others by which you can save. As we just now heard from Kuhn that we have a very large scrap factor. That is because we are trying to do everything from a solid and then try to carve it out. But if we can really shape it, and in shaping we should not use casting or a forging because these are very ineffective processes which has been now found out. So how do we do it by metal forming? and doing that metal forming to the near shape so that you don't require much of a material removal in these things. Lastly, I think a lot of revisiting AS 9100, which is a mandatory certification. We should not really forget the principles of AS 9100 and the NADCAP certifications for the special processes. So we brought in that once again a refreshers course for everyone. And before I just leave this particular discussion, this particular topic, I think we also utilize some of our known technologies, what we brought from aerospace, and converted them into a spin-off for the other industries. And as you know that during the pandemic, we had a difficulty in getting the ventilators. And the ventilators then were decided that Bharat Electronics will integrate these more than 50,000 ventilators, and they were not getting solenoid valves. So we used our technology, and even during pandemic, we were able to start and operate and could convert our shop into a proportional solenoid valve manufacturing unit and produce more than 5,000 valves in just 2 months and gave our support or kind of a contribution to this pandemic to the Indian nation. And today I'm very proud that of this 50,000 the ventilators, 5,000 actually ventilators are working on the walls what we have supplied. So I think the spin-off is also what we are looking. And similar spin-off we are looking into the other healthcare equipments. And fortunately, NITI Aayog plus Government of India has decided that henceforth they will not be really looking for import. Today, to my surprise, I was really surprised that 90% of the medical equipments or the healthcare equipments are imported. They are not even assembled in India. And that's a really work factor. And we know in aerospace such a large amount of technologies and the criticalities. So for us, it took just 8 days to develop that solenoid valve. So if we really put our brain, if we really work on this public-private partnership model, I think we can do wonders and miracles. So with this, I will stop here. Thank you once again. Back to you, Mr. Paltan.
Thank you, Surendra. I think that was very vivid. You brought out the challenges. You did not allow them to overwhelm the organization, rather found the opportunities out of that. And some of the cues which you have given are applicable to other industries also. Particularly what I noted as a broad-based, this thing was de-risking by moving into different verticals, so that if one vertical, the business is going down, you have others to back up. And the other one is on the spin-offs, work on the spin-offs from the industry, own industry's strengths, so that at such a time, which we think is continue for some more time, it's not going to be, impact of COVID is not going to vanish in a hurry. So these are all very relevant. Surendra, thank you very much for that. And with that, I would like to now again go back to Ramesh. How they converted the challenges into opportunities. Some of those are applicable to the industry at large, taking a cue from the own experience for Godrej, like they deal by diversifying into all the possible verticals in aerospace, civil, military, as well as space, so that as the businesses go up and down, they can balance out. And the other one is working on the spin-offs that can be derived from one's own industry's strengths. So with these opportunities and the possible avenues, in your opinion, what are the strengths of the industry in general that can be leveraged for making use of these opportunities, which earlier Bendu had mentioned about the various government measures and from our own industry experiences? Ramesh.
First, I will speak about how we got over these challenges and in general, what the industry is facing, what are the challenges of aerospace sector. First thing is, as we all know, the orders did really reduce marginally, at least. And obviously, there's no way we can say that, yes, we have got less work. During the COVID period, chasing the customers, somehow we got few new orders and we delivered it. And apart from that, some of the suppliers had difficulty in machining and supplying the parts. This is where we really did some smart way. We pulled back those orders in-house temporarily. We did that work for them and we managed the show. This is something which was fabulous, so that the work will seamlessly move on and customers will get their orders. Remember, I said we have 2 plants in UK from where we were supposed to get the machine parts, and which was a challenge at that point of time, somewhere in April, May. But still, we managed that one. The third one is definitely it was a reinventing, or we realized the strength in how we can digitally get connected with others, including the customers and the suppliers, and see that material movement is not hindered too. Can you imagine during the COVID period, we had the LCA front fuselage handed over to HAL, and we had the HAL chairman in plant to accept the fuselage. I mean, that was the challenge. We said, yes, we will make it and make it happen. And the 2 orders of Boeing, we did deliver during the COVID period. These are the new orders, which were apart from the routine orders, and they gave it as the pillars, and we did manage. These are the things which flexibility, keeping flexibility, quickly moving around and moving the people, and including from the suppliers' orders, bringing it in-house, we kept every worker and every machine occupied. Okay, apart from that, if I can speak about the general challenges of aerospace industry, not particularly about dynamatics. For some reasons, I will not quote the examples of dynamatics. But what we have been finding is shall I continue, Dr. Padu?
I think if you can conclude it quickly, that would be helpful, Ramesh, because I want to just go over to Srinivas and Dipendu also for some questions.
Yeah, then no problem. Whatever the points I have about the opportunities we have and challenges we have, I have a few lists which I can share it later after others speak about it. Thanks, Dr. Back to you.
Thank you, Ramesh. Dipendu, I'll come to you. There have been talk about skill build-up, which you had also mentioned, and Surendra also talked about it. I think that's an area which all the industry has to focus on, making use of this, if I can say, not adverse, but the lean period. Could you very quickly and briefly tell us how HAL can contribute to this, because we all know HAL's great contribution in its own internal skill build-up, but in the external industrial ecosystem, how HAL is doing it, or how it would be planning to do going forward. Dipendu.
Yeah, thank you, sir. As far as skill building is concerned, HAL has its own facilities. Like we have got world-class facilities called HAL Management Academy, wherein we are offering a lot of professional courses for our own people as well as for other people outside HAL. So this facility can be utilized, wherein we are giving a lot of professional courses also. And I'll just briefly tell what are the courses that we do offer here. I mean, and we are also doing a lot of courses for our internal people.
Maybe I can just interrupt you.
Yeah.
The paucity of time, because we have to allow time for the audience also to interact and the questions. So instead of the courses, which perhaps can be, in whatever manner HAL thinks it can be broadcast to the industry at large. So very quickly, I will ask a specific question. Would HAL accept people from private industry to send to its management academy or any of its training programs in the technical training schools?
Yes, we do offer a training program to other industries also, and whoever is interested can contact our Management Academy in Bangalore.
I think that's very useful. Thank you very much. I think that's a good input. I want to come back to Srinivas. We have heard, various measures taken by the industry members. You had narrated some of the challenges in terms of regulations and rules. Apart from that, do you think there is any other gap area that needs to be fixed up, either with government help or by the industry on its own? Like our other friends have narrated their own experiences of it. Do you have any point in that direction, Srinivas?
Yeah, yes, sir. If you see, recently government has withdrawn, like some kind of export benefits where you are getting earlier for this. That is for every industry, not only aerospace industry they are giving. Now they have withdrawn across the industries, export the benefits they removed, because earlier we used to get, whenever we export, because we do around 85% exports. So we used to be more competitive by taking that into the consideration. Now that is being removed. Maybe we need to re-represent the government, at least for aerospace industry is more largely dependent on import as well as a thing. I feel that maybe we need to put a representation. Maybe for other industries, if they're not giving, at least for the aerospace industry, they should give this benefit for another 2-3 years so that we can sustain and we can we can be back on the track, because we're struggling right now, as you know. The worst hit in the century, we can say. We've never seen in our entire generation lifespan.
Yeah, thank you. That's a useful input. Maybe you can include it in what we discussed earlier.
Yes.
Now, before we close the discussion points, very quickly for a minute, anyone would like to talk about, because we have talked about our experiences and industry at large, but there is a lot of focus on MSME industry. So, some quick points, maybe like bullets. Would any one of you like to say what needs to be done, or what is the attention needed for MSMEs in the sector? Ramesh and Surendra.
Yeah, I'll speak on that, Dr. Palta. One is the biggest challenge we all face, I'm talking in general, is the special processes. Quite often we have reached to Europe to get one small item cadmium plated or welded or something like that. And there was what I remember is the state government came forward that they would put up a center of excellence for the special processes in aerospace hub. And we wish and we request government to look into it and do it faster, because for a smaller quantity, for each industry to establish its own special processes will not make it cost-effective one. Apart from that, as others panelists already mentioned, there are certain benefits for a export-oriented companies, like the MEIS, which has been now trying to put in a different form, and excluding the UOUs is not a welcome sign. That should be put back. And there are other ones I always keep telling about the raw materials availability. It's a big challenge which government should take it up seriously. Can there be an Indian suppliers who can be upgraded or can be supported so that they will get approved by the major OEMs, so that we don't need to always fall back upon the Western sources for even a small fastener or a cable or a raw material. See, some of us are depending on the domestic orders, from the PSUs, from elsewhere, whatever may be the domestic orders. And those who are really depending on the domestic orders will face one problem: low volumes and a long time. And margins are not that very can be really happy. Apart from that, my point here is sometimes certain Indian OEMs will insist on the bank guarantee for the whatever we deliver. That should probably should be looked into. When a supplier, tier 1, tier 2 are struggling, having invested huge, on top of that, bank guarantee may not be a good thing to as an encouraging an industry. That's only my point. I mean, this is my submission. Yeah, back to you, Dr. Patel.
Thank you, Ramesh. Surendra, I think we would like to leave you before we close.
Naresh, I think I have two suggestions, one to government and one to all of us as an industry and industry body. One is that I think government has given a lot of now push to the defense sector, the military sector. But as I said, it's not really sufficient to give a push to military sector. We also had a civil aviation in cards, and we wanted as small as 14-seater Saras manual to get manufactured in larger numbers, and then HAL was trying to do at Kanpur. I think the two of the aircrafts, the 23-seater and 28-seater, was what they were making. But I think there is a good push is required to the civil side also, because finally, if the civil side is growing at 20% or something like that every year, I mean, forget about this pandemic year, but naturally. So we will require a larger aircrafts, and India unfortunately doesn't have a good program in this. The second to industry body is that I think we all together have still failed to convince PRI that they should have their office here. If we want to be really successful, we should have more Indian auditors. We should have PRI office as they have it in China and in the Europe. We should have definitely office in India, which can serve the rest of the Asian countries also. And that is going to tremendously benefit us getting our certifications at a cheaper rate and at very easier dates and with less of a coordination. Thank you.
Thank you, Surendra. Thank you. And all of you have given very good inputs. Thank you, Ramesh. I think that can be consolidated into what Srinivas is going to put for help needed from the government. So if you can join in into that, then we can take it up offline. Thank you once again, everybody. It was a very enjoyable session, and let's now open to the audience.
Thank you, Dr. Palta and panel members. We have in fact suggested that if participants want to ask a question, they can raise the hand. I don't think we have seen any hands in the chat box. Do we have any questions? Maybe we can pass it on to Dr. Palta. I'm just checking with our IT team. Any questions, Ilango? Dr. Ravikumar raised a question. Dr. Ravikumar, would you like to ask? We are unmuting you.
Yeah, are you able to hear me? Sir,
Yes, you're audible, sir. Go ahead.
Excellent. So, sir, it's a wonderful presentation of the Indian manufacturing scenario. A lot of good things you talked about. I just want to ask one question. What is your suggestion to young engineers who want to pursue a career in aerospace manufacturing? Any guidance for them?
Thank you for your appreciation, Dr. Ravi, and this question. I'm reminded of my college days when we always used to get some questions which are not in syllabus. And I think your question is something of that sort, means it's beyond the topic that we are discussing, but notwithstanding, I definitely would respond to that. Today, what I find that when the youngsters come into the industry, they are not industry ready. And whilst it's very easy to say, oh, these youngsters are not getting themselves prepared, but I think that a lot depends on the institutions also. Fortunately for me, I also get some exposure and involvement with some of the academic institutes. And I always give this message that the institutes must reorient their curriculum to make these young engineers know what happens in the industry. Because otherwise, what happens, they leave the books, take their degree, and come out into the field, and it's a totally different world. And of course, the message has to be for the young engineers also that they have to be abreast of it. From the days when I was in the engineering school, and now 50 years later, the world is different. The communications have changed. There is the internet and all. It's a global village. So they themselves also have to make the best use of the resources available. Like I said, internet. In our days, we just had to go to the college library, and that's it. And today they can have a reach to anything and everything in the world. So they also must try to understand what the external world is, particularly when they are going for their internship. I think that's an occasion which each engineering.
To add to Mr. Palta's point, we have in India plenty of aeronautical engineers are coming out, but they actually they teach something on design and all, but they are not useful to manufacturing industry. So the institutions have to look into this. As Palta sir is advising, they need to do they need to look into the courses so that they once they come out, they should be able to. Now, right now, a mechanical engineer can work in a manufacturing aerospace industry, but whereas aeronautical engineering people are coming out, which they will not have the not much of manufacturing knowledge. I think we should really look into that, and but the quality of the institutions need to be increased.
Dr. Palta, if I can, based on our experience in Dynamatics, is one simple rule or the mantra to keep the youngsters is keep them engaged all the time. Empower them, allow them to experiment and innovate, of course, with some supervision there. That's what makes them identify themselves with the company and grow in the company and will stay longer. I mean, this has been experienced and we feel this works very well with the youngsters. Thank you again.
Thank you, sir. That answers my question. Thank you.
Do we have any more? The IT team.
Video. Yes, Dr. Palta, we have few questions on the chat box. Is it okay if I read out on behalf of the attendees?
Oh, that will be great. Yes, please.
Okay, sir. I have a question. Hello?
Go ahead.
Hello, sir. I'm Amanvi. I'm studying in Chennai. So during pandemic, for aerospace engineers, we've been sitting at home for a long time, and for us, the most important is practical work in field, hands-on work. So we haven't been able to explore most of the part during this our holidays, and as a part like we're not engaged the studies also too much. So with this 1 year loss, how can we cover up fast? Any ideas, any suggestions, or anything to look up so that we can come back with this 1 year very quick and fast, so that we can clear a backlog very quick?
There are two aspects of it. One, you have talked about, you have been sitting at home because the academic institutions were closed. Well, that is something I'm sure all the institutions today, from what we see in the media, are working on it, how to recover the lost time and compress some of the build-up of the learning. The other aspect about learning from the industry, I am aware of one or two instances where youngsters like you approached our company and we were able to take them on board as interns although because of the financial crisis, there were no compensation paid, but those people were very happy to have very fruitful utilization of their period. So I think in your vicinity, there are in Tamil Nadu, we have such a large bank of industries. You should approach them directly and seek, and I'm sure the industries would be very happy to help you utilize your period outside the institute.
Thank you, Naresh, sir. I'll keep that in mind. Thank you very much.
Thank you, Dr. Papata. Can we move on to the next question? Do we need to increase investment in quality and metrology applications to be able to go up the value chain?
I don't think there is any other answer than yes, and a capital yes.
You're right.
Because many times when we talk to our customers, and I have been on the other side as a part of Hindustan Aeronautics building the aircraft also, quality is a given. I will just narrate the instance so that very directly answering. We were delivering the Fokker 50 horizontal stabilizer to Fokker aircraft, which now is not in existence. And their chairman was here in Bangalore to receive it. And whilst I was escorting, as a small conversation, I was briefing him, what all we have done for the first tail plane to be ready, and its quality first time right, and etc. etc. His immediate reply to me was, "Young man, quality is a given in the aerospace. I don't even want to hear about it. You have to deliver it on schedule to the right price, and I take it that you will deliver me the quality goods." So yes, absolutely, we have to invest in that. That's a very, very essential element of aerospace industry. I hope I have answered that.
Yeah. Thank you, sir. There are 3 questions related to 3D printing from Monotech. How is 3D printing making a difference in India? And then how is 3D printing, how can a company like us in 3D printing join Atmanirbhar Bharat?
I'll ask first my friends whether anybody would like to take this question.
I would like to add a few tools in this. DHL actually using 3D printing for developing the prototypes, which is definitely a very fast process, and the corrections can be incorporated very quickly, and which is a lot of time. So that is the first application for developing all the prototypes, and when it is a concurrent production also, design development as product and production concurrent process. So there, 3D printing plays a very important role. Also, we have now started manufacturing airborne components through 3D printing. Like Su-30 also have used some components in the fuel system. So definitely 3D printing is going to play a great role subsequently.
If I can quickly add to this, we did replace some of the components with one of the Western project with the 3D printed components. You know that volumes will be always less with any aerospace project. And if it's not a stressed part, it's not a structural part, it was much easier for us. And we did change some parts, and it was a great success. And the customer also supported us in quick approvals. So it is possible. It's picking up this line.
Thank you, sir.
Vaidya here, can I add something?
Yes, sir. Please.
Yeah. Sorry, probably my video is not going to get telecast. There is a small problem with the bandwidth
issue. That's okay. Go ahead.
So I will just make a caution here. I mean, everyone is excited on the 3D printing, but just a word of caution so that we don't get too excited, overexcited onto this. There are 3 things which are holding 3D printing to really come into a mass production. One is that there is no so far good ASTM, ASME standard which is explaining the 3D printing as to how this can be really accepted. every part is treated as a new part. So it's not like a plate where once you take a small sample from the plate, the rest of the plates or the heat can get tested and accepted. And the third is, as far as the non-destructive tests are concerned, there is no so far established technique. And the techniques which are established, they are specific to the job. So unless and until you are prepared to do a lot of R&D, 3D printing is not good. However, no one stops you from using it into a R&D project. No one stops you from using it for your quick dies and punches so that you can develop the product quicker. So I think currently the scope is limited to doing the R&D and not much into the production unless you have your own product and you will be able to certify and ascertain it. If you are going to do a build to print somebody else's design, then it's not something, a process which is of the current day. Thank you.
Thank you, sir. I'm just sensitizing everybody on the time check. We are at 5 minutes overshot. So, Dr. Palta, can we take few more questions or should we conclude?
How many are left? Depends on
Okay,
that.
there are 2 more questions.
Let's see, we'll very quickly handle these.
Okay, how to bring Airbus and Boeing manufacturer in India as Indian civil aviation industry is growing exponentially from A193?
Airbus and Boeing, they have a good presence in India in terms of the supply chain here. If I remember the number recently in one forum, Boeing director had said they have more than 200 supply chain partners. So they are there. They are very much present in India. And I can only, for the sake of history, tell that they came to India with HAL in 1989 and 1990. So they are present here. What was the other question?
Yeah. Thank you, sir. The last question for the session is, it's a generic question from Mr. P. Rohit. What lacks India in manufacturing civilian aircraft or commercial aircraft?
Well, see, we have some programs which are on the anvil, but we haven't put, if I can play it straight, we haven't put our heart and soul as a nation, I would say. I would not like to blame because we are all in the same domain, the government, the private sector, the public sector, all the people are in the same. But I think as a nation, we haven't done our bit and we haven't driven the way our neighbor has done. When China started with their civil aviation program, we also were talking at the same time. And interestingly, some of you might like to know that the discussions were held with China also for partnership. But we didn't take it forward with the same enthusiasm which they have done. And even Brazil at that time was just in the nascent stage. That's exactly, it's a policy decision which has to drive it. Thank you.
Thank you, Dr. Palta, and all the esteemed panelists. I think we were fortunate to have such high-level technocrats in our today's webinar. Thank you so much. We are moving on to the next session.
Thank you.
Thank you very much. Thank you so much.
The organizers, and thanks to all the audience.
Ladies and gentlemen, the next one on the agenda is the keynote address, the technology theme. The topic, relevance of Industry 4.0 in Indian aerospace manufacturing during post-COVID era. The keynote address presents a quick overview of Industry 4.0 in aerospace, its relevance and current status. In the post-COVID era, Industry 4.0 technologies can provide a lot of support in improving the manufacturing efficiencies and reducing the costs. This talk can provide insights on how Indian aerospace industry can get benefited by implementing Industry 4.0 technologies. And for that, we wanted to invite Dr. Ravi Kumar, GVB. He's the Associate Vice President and Head, Advanced Engineering Group, Infosys. So Dr. Ravi has led numerous innovation and applied research projects over the past 20 years. His areas of expertise includes mechanical structures and systems, knowledge-based engineering, composites, AI, robotics, autonomous systems, AR, VR, and Industry 4.0. He is involved in the development of commercial products like Autolay, which is basically CAT's Composites, a spin-off of Indian LCA, that is Tejas program. Neo Knowledge, a knowledge-based engineering platform, and Kirti or KRTI 4.0, an operational excellence framework. He contributed to many Industry 4.0 implementation projects and played key role in development of Industry 4.0 Maturity Index under the umbrella of AK Tech, Germany. He is also involved in various initiatives of WEF, World Economic Forum, Fourth Industrial Revolution Technologies in Production. He is a member of HM1 and G31 technical committees and the chair of G31 Technical Committee of SAE International. And Dr. Ravi Kumar has published over 50 technical papers, 4 patents, 2 granted and 2 filed. He has a doctoral degree and post-graduation in applied mechanics from IIT Delhi, and he has the undergrad from BITS Pilani, India. He is also the technical committee chair for our Aerocon 2020. He is contributing a lot to SAE India. Over to you, Dr. Ravi Kumar.
Thanks a lot for that wonderful introduction. I take this opportunity to thank SAE India and IDAT for giving me this wonderful opportunity to speak to you today. I'll be talking on relevance of Industry 4.0 in Indian aerospace manufacturing during post-COVID era. Let us take a brief look at the entire aerospace industry so far and the challenges that industry has faced over the years and see where we are. During initial days of aviation industry, a lot of focus was there for ensuring safe travel from point A to point B. Whether the travel through air balloons or the first flight or the rotary wing innovation are aimed towards safety during initial years. And mankind was able to overcome this particular safety challenge. Then the next major milestone was meeting the security challenges. In fact, 9/11 has given severe security challenges to the aerospace industry, and we were able to put many measures in place to ensure secure travel for the passengers. Then in 2020, we are facing this global pandemic, and it has raised many health issues and also many health concerns on the air travel. In fact, aircraft industry was severely impacted. If you look at on Jan 7, 2020, we have around 39,000 plus aircrafts flying across the globe. And by April 7, 2020, this number has gone down substantially to 4,000 plus aircrafts. And the kind of impact and the scale of impact is unimaginable. If you look at air passenger traffic has come down by 60% in 2020 compared to 2019. Airports have incurred huge losses up to the magnitude of 64% of passenger traffic. Airlines has a decline in revenue by over 66%, and tourism dropped substantially. Of course, it has a severe impact on the trade and the global economy. And because of this, aerospace industry has flown through many turbulent phases. And if you look at the entire commercial aerospace industry, the scale of impact is indicated in this atypical mind map. So if you look at this particular chart on the left side, there is a big decrease in demand for flight hours due to COVID. Due to that, it will have more number of grounded aircraft. When many aircrafts are grounded, the demand for MRO is reduced substantially, and also the demand for spare parts. And also, supply of disassembled spare parts are increased, and that will further reduce the demand of spare parts. Similarly, the demand for new aircraft is also reduced substantially, and in fact, on the right side of this particular flow chart gives a kind of pictorial representation of that demand for new aircraft. Cash flows, constraints, and also decrease in oil prices has led to decrease in rate of replacement of aircraft. And that in turn decreases demand for new aircraft. Actually, there was a prediction that in next 10 years, from 2020 to 2030, we have predicted close to around 21,760 new aircraft that are required. But this can decline by over 50%, so which means it's a substantial reduction in the commercial aviation sector. Of course, defense aircraft sector is not impacted much, but the scale of impact on the commercial aviation industry is substantial. And what we need to do as an industry together is essentially we need to collaborate. The entire industry has to collaborate. They have to come much closer than ever before. To start with, this collaboration has to happen at all levels, whether it is a business function level or at an enterprise level or at an extended enterprise level or ecosystem level, mainly to meet the challenges that we are facing today, to keep the environment sustainable, to increase the security, to increase the health and safety, reduce cost of operations, and increase efficiency across the aerospace value chain. That's the need of the hour. Technology can play a vital role in increasing the efficiency across the aerospace value chain and also meeting some of these challenges. Industry 4.2 is one such answer. Let us look at the landscape of Industry 4.0 or the Industrial Revolution. In the initial days, what we call it as Industry 1.0 is all about mechanization. Using mechanical assets, you are able to automate certain things. Then the electrification has come. During that period, the period of Industry 2.0, we have used the electrification of the machines to automate the processes. Then the third industrial revolution, Industry 3.0, came in. It is all about automation. The industrial automation has helped us immensely to improve the efficiency. Now we are in the fourth revolution of the fourth stage of industrial revolution, which is all about cyber physical systems and their interaction, more specifically the IT/OT integration. It's all driven by smart connected enterprise. This revolution is all about connecting various technologies horizontally, that is horizontal integration from supplier to manufacturing shop floor to the end customer, and also the vertical integration of various technologies right from the asset in the manufacturing shop floor to the top floor dashboards. Okay? And this is enabled by various advances in technologies, whether it is in the name of cyber physical systems or seamless interoperability or advanced automation and control, big data processing and analytics, or the smart services that we have today. This entire thing, or the entire fourth industrial revolution technologies, are helping us to establish end-to-end digital thread of the physical world across the manufacturing value chain. What is it implied to? It is helping the organizations to improve their top line by improving their business growth, by creating next generation products and services. These we can call it as smart products and smart services, and also helping improving the efficiency of the manufacturing shop floor by way of connected factory and also the smart production. This is one of the low-hanging fruits for the manufacturing industry to take note of it. And if you look at improving the efficiencies, you can improve these efficiencies across the value chain of an engineering organization, whether it is in the engineering side of it, or the supply chain side of it, or in the manufacturing operations and services. Okay? So if you look at engineering efficiency, in fact, this is the first thing that most of the industries have looked at by way of utilizing some of the CAD, CAM, CAE kind of tools to automate the processes and also improve the efficiency. Later, we have used a lot of these knowledge-based engineering systems to automate the processes. Now people are using model-based systems engineering to improve the efficiency in the engineering side of it. Then the supply chain side, supply chain efficiency, where you have a lot of these technologies that are there. These are around track and trace related technologies. Through that IoT technology, you are able to track the assets, where they are, when they are going to come to the manufacturing shop floor, and things like that. Through that, you are able to identify, assess the problems, and solve the problems that are there in the overall supply chain, thereby improving the efficiency. Then the manufacturing shop floor comes in, where you can look at improving the operations efficiency, improving the maintenance efficiency, information efficiency, and energy efficiency. These are the four broad dimensions of efficiencies that you can look at it. And Industry 4.0 technologies, whether it is the IoT or the real-time visibility or the kind of technologies that are there in terms of automating the processes using the robotics and AI, you can improve the efficiencies of the manufacturing shop floor substantially. Once the product goes out of it, it's all about service efficiency. How do you help your customers reducing that cost of ownership? More specifically, reducing the maintenance cost and reducing the operations cost. In fact, some of the numbers that we are showing it here, these are all conservative numbers. You can achieve much more better numbers than that is shown here. Essentially, if you look at in this particular slide, you have close to around 20 to 30% reduction in energy consumption. But this can go up to more than 50% in some times. In the sense, what I would like to say, the bottom line is, when you use these technologies, you will be able to improve the efficiencies substantially. That will help in reducing the cost and improving the productivity. So what we need to do for this Industry 4.0 transformation, in fact, there are many frameworks that are available. One of the best frameworks that we could help in creating is the architect framework. In fact, we have worked with University of Aachen under the umbrella of architects, along with other university partners and the industry partners, created this particular maturity model, which will help you to understand where you are currently in terms of the Industry 4.0 maturity, and also where you need to go in the next few years. So if you look at this particular maturity model, there are 6 levels of maturity. Initial model is all about the computerization. Okay, so most of the industries, they have computers which are being used to utilize some of those data entry operations, data automation operations, and things like that. Then the connectivity part of thing comes in. That is essentially connecting these computers with various other assets that are there. And then the first level of maturity, as far as the Industry 4.0 is concerned, is all about the visibility. So visibility talks about how best you can collect the data from the machines and bring it to the top floor. Okay. This is essentially to understand and also bring the data automatically to improve the process or to improve the efficiency of the machine. Okay. That's very, very key, because until and unless you have the data, you will not be able to do anything. Okay. The first phases of Industry 4.0, which is about visibility, is all towards that. Okay. Connecting the machines real time, getting the information real time. Then the next phase comes the transparency. That is all about understanding the data, that what you brought to the table, and seeing what is happening, why is it happening, how is it happening, all that stuff that you can look at. Okay. So once you make the data transparent and also you are able to understand the major issues, then you can naturally predict what is going to happen. So that's about the third stage here. It is all about the predictability. So if you are able to predict certain behavior, that there is something is going to happen in future, you can prepare for it. One simple example is whenever a particular machine is giving a trouble, you can assess the remaining useful life of that particular machine, saying that, okay, next 1 week, this machine is going to give problems. So let's initiate all the troubleshooting activities right away in terms of the manpower, material, and also tools that are there, so that you can reduce the downtime. Okay. So once you have this predictability stage achieved, then the next stage is all about adaptability. Okay. So here, automatically analyzing the data, predicting what is going to happen, and controlling the machine. So adaptability is all about self-control. The machine taking control of it to improve the overall process. Of course, this is a high target to achieve, but most of the industries are moving towards that particular stage. So let's look at the relevance of this for the manufacturing shop floor, more specifically for the aerospace manufacturing shop floor. Most of the aerospace manufacturing today is either metal or composites. Of course, composites are the wonderful materials which are widely being used in aerospace, and composite materials are going to be the future in future. So that's the reason why I just took the composite manufacturing shop floor. So here, if you take a typical composite manufacturing shop floor, you have various things, whether it is the cold storage facility, which is used to store the material and also all other equipment. Then you have the testing lab to test the material and also the products. Then you have various other machines that are there, whether it is automated tape laying machines or the automated fiber placement machines and things like that. Then you have the vacuum bagging facilities. You have other equipment for the layup and other instruments like cutters and things like that, which are used to cut the material and things like that. So in one way or the other, if you look at this entire manufacturing shop floor, you have raw materials, you have critical equipment in this manufacturing shop floor, and you have the end product that is being produced. So in each of these things, you need to look at it where you can improve the efficiencies, how you can improve the efficiencies. Okay. So in one way or the other, there are other important critical equipment that is there, which is essentially the autoclave, the ovens, NDT testing facilities, and things like that. So you need to look at it holistically. How do you improve the overall process? So in one way or the other, if you summarize this manufacturing shop floor, you have raw materials, which are having time-dependent behavior. In fact, the carbon materials or the prepegs that you use, they have certain life. Okay, you should use that material within that life. Otherwise, you will lose that material. Then you have a lot of equipment that is there, whether it is the cold storage facilities, stapling machines, and things like that. You need to improve the efficiencies of this machine. Then you have the output, the product that you have made. That product need to be assessed for its quality and also the specifications that have been laid out. Okay? That's how it looks at it. So while you have this overall input and the equipment and the output, you essentially looking at certain key KPIs to improve the efficiencies, right? So whatever efficiencies that I have just mentioned in terms of the operations efficiency, maintenance efficiency, energy efficiency, you can put those things in certain key parametric improvements or the KPIs, okay, which you will be tracking to improve the overall efficiency. Okay? This entire thing is built on top of the information efficiency, which is essentially the data layer that you are getting from the machines and utilizing that data to create these KPIs and also monitor those KPIs. So most of the KPIs, if you look at the OE, is one of the biggest KPI that everybody looks at, operational equipment efficiency. Okay, so this particular parameter is being tracked by production engineers right from the day one. What is this new that you are getting it in Industry 4.0? In Industry 4.0, what you are getting is the data is captured real time or near real time. Because of that, the OE can be computed real time or near real time. Because of that, you will be able to assess the performance of that manufacturing shop floor real time or near real time. So that is a big benefit that you get. If you are able to understand the performance continuously, then you are able to track that and improve the efficiency continuously. Otherwise, if something has happened, you came to know 2 days later, and those 2 days were most valuable for you, which you lost. And that has created a big productivity loss for you. Okay? That's the kind of advantage that you get. Okay? Similarly, on the equipment side, whatever equipment that we just mentioned, whether it is autoclave or NDT, you can identify various failure modes and track those failure modes through the sensors that you have put on the machine and understand how this machine is performing and make sure that that particular machine is available and that particular machine reliability is continuously assessed. So that's what you do. Identify those key failure modes and go after with each one of them so that you can track them and also rectify those problems. Okay. So in one way or the other, Industry 4.0 technologies can help monitor the raw materials and tools. Okay. Whatever process that you have earlier, which may be substantial manual processes, all the manual processes can be automated using software and hardware equipment. Okay, there are a lot of these technologies that are there now, more specifically the RFID tags, QR codes, and other hardware technologies. You can use that to track the materials, its life, so that you can reduce the waste. Similarly, all the tools that you are using in the manufacturing shop floor, you can track the location of those tools and make sure that those tools are available at the right time so that you can improve the overall productivity. And that is very, very critical for you. Then the other one is all this critical equipment that is there, whether it is autoclave or other assets, you can track the performance of that particular equipment continuously through the sensors, use the data to understand the performance of that particular equipment and improve the performance of that equipment, and also predict any kind of downtime that is going to happen in future and rectify that particular problem. So this essentially you can do by way of reducing the mean time to repair, okay, and also improving the overall availability of that equipment and by way of improving the reliability of that particular equipment. So that's what you can do. In one way or the other, if you look at the Industry 4.0, can provide a substantial benefit by putting an AI layer on top of the data that you have collected, make the entire enterprise smarter, okay? So that the machine can identify the problems that are there and use that information to improve the overall process. This is the typical architecture that has been put here. What essentially I would like to summarize here is you are able to capture the enterprise data that is coming from various enterprise systems. And also you can capture the data from the machines and use that machine data and the enterprise data effectively to build the knowledge models, the prediction models, and the real-time dashboards, and use that information to improve the overall business. And also the downstream processes in terms of the asset management systems, asset operation systems, and things like that. In summary, what I would say here is Industry 4.0 will help in improving the operation technology much better and also capture the information that is coming from the operational assets much better. Use that information to enable greater transparency and also to improve the comprehensive reporting, decision support, state-of-the-art workforce management. It can help in reducing the waste, reducing the manual processes, and also can help in capturing the knowledge that is out there with the technicians and utilize that information to improve the overall process, reduce the risk by AI and the advanced analytics. It can help in improving the overall product, efficiency across the value chain, safety, security and surveillance, and sustainability. That's all for today. I'm open to take any questions. Thanks for your time and look forward for your wonderful questions.
Hey, unmute. Thank you, Dr. Ravi Kumar. That was concise. In about 25 minutes, you have covered the 4.0. Any questions? Any raise of hands in the chat box? Chat box, please. Okay, no questions. So thank you, Dr. Ravi Kumar.
Thank you. Thank you. Thanks a lot.
So ladies and gentlemen, we are moving on to another interesting panel discussion. What we saw earlier was the business, and now it is a technology panel discussion on challenges and opportunities in implementing Industry 4.0 in Indian aerospace manufacturing ecosystem. This is for about 45 minutes, and the objectives of this panel discussion is to deliberate on the current status and future roadmap in implementing Industry 4.0 technologies in Indian manufacturing ecosystem. It focuses on current challenges, opportunities, areas of focus, India's strengths and potential, best practices and standards for implementation, tools and technology landscape, skills and training, and change management. And the format we follow, because of the technology hitches we faced earlier sessions, 30 minutes of the recorded sessions of the panelists and then 15 minutes live Q&A. Panelists are available, and you will have to excuse us for a very short introduction of the eminent personalities. Each of them has at least about 2 pages of accomplishment, but I am going to pick out a few paragraphs. It will be moderated by Dr. S. Christopher, Chairman IDAT and former Chairman of DRDO. Dr. Christopher is currently working as a professor at IIT YAM, and he is a chairman of IDAT. Prior to becoming Secretary MOD, Dr. Christopher, distinguished scientist, was a director of the Bangalore-based DRDO lab, the Center for Airborne Systems, and program director for prestigious AEW&C program. He was the chief architect of AEW&C system, responsible for its design and development indigenously, which placed India in the league of 4 nations in the world. During his tenure, DRDO completed several indigenous systems, got inducted into the system, to name a few: AEW&C or Netra, LCA or Tejas, or even Akash missile system, nuclear submarine, torpedo, Varna Sutra, and many more. He is the recipient of several awards, including prestigious Scientist of the Year in 1998. I am moving on to introduction of the panel members. The first panel member, Dr. C. Gajendran, COO of UCAL. He has more than 35 years of experience in aerospace industry. He's got his doctoral degree in rapid manufacturing 3D printing technology from Penn State. And Dr. Gajendran was also a scientist G and group director at ADA and DRDO earlier to this position. He was responsible for LCA prototype development and subsequently for building technology demonstrators of Tejas aircraft. He was honored with the Best Scientist Award in Aeronautics in 1994 and National Integration Award in 2004. He has acquired several accolades and awards. Some of his notable projects include ALH Design and Development, LCA, and Amphibian UAV. The second panel member, Nikhil Joshi, head of Eaton Aerospace Bangalore plant. Nikhil leads Eaton Aerospace business in India with a greenfield facility manufacturing fluid conveyance product for aerospace industry. It is located in the Aerospace SEZ in Bangalore. He is a graduate from NDA Karakwasla and Indian School of Business Hyderabad, and accumulated over 23 years of leadership experience in military and corporate domains. He is a qualified military pilot, has commanded frontline warships and air squadrons, and led operations and strategy in headquarter roles during military career. With Eaton, since 2018, he has led the project to build, establish, and operationalize the new aerospace facility. Mr. Nikhil is passionate about aviation and digital transformation and is currently leading the effort in a pilot project to deploy Industry 4.0 tools and processes at the Bangalore plant. The third member of the panel discussion, Mr. Ravi Kiran, Director Aerospace and Defense Dassault Systems, also known as 3DS. Ravi Kiran leads Dassault Systems A&D marine and offshore business in India. His role is to define the business strategy to expand Dassault Systems solution footprint in India and ensure successful execution of key defense programs. He started his career with Dassault in 2004 and donned various roles within the product development team. A graduate of premier academic institutes IITM and IIMB, he is also a member of several industry bodies such as SAE, IFCCI, and he is a recipient of the prestigious DAAD Fellowship from Germany. Panel member 4, Mr. Ramachandran N., Managing Director, MEL System. He is an electronics graduate from MIT Chennai and received his management education from IIFT Delhi. He has over 4 decades of experience in electronic industry in various capacities. He is now the managing director of Mel Systems and Services, a company engaged in automation and control, defense electronics, automatic test equipment. He has varied interests and is involved closely with the alumni associations of MIT and IIFT. He is a recipient of many awards, including Outstanding Alumnus Award from IIFT, Distinguished Alumnus Award from Anna University, Lifetime Achievement Award in Electronics from Elsina. Ladies and gentlemen, now is the panel discussion, and welcome panel members and panel moderator, Dr. S. Christopher. Over to you.
You are aware that the SAE India and the ADAT has given us chance to have this discussion in this webinar, Indian Aerospace Manufacturing Business Imperatives. We have a good panel, and I'm sure I've got a better experience. They will be able to give good inputs to you. We have a topic today, challenges and opportunities in implementing Industry 4.0 in Indian aerospace manufacturing system. As you are aware, when the Industry 3.0 started, the world went through a lot of transformation in terms of automating most of the manufacturing. Obviously, when eyebrows raised, questions were asked, automation can take a job opportunity or lead to some sort of errors and mistakes. However, most often we have man in the loop, and still we have many systems totally automated, but still overarching or overlooking some sort of a man in the loop is always there. Recently, when we started thinking about Industry 4.0, we are trying to digitize. Why? Mostly we would like to have all the input, which otherwise as a human being may not be able to handle it or may not be that much informative. We would like to have a quick decision based on very vital information, but not all the information. So the digital input in Industry 4.0 can give much more insight to the process, and thereby our manufacturing could be even better. That's one side of the story. The other side is, once you have in a digital domain a good amount of computation, what human being cannot instantaneously do it, can be probably done at the background, and even certain amount of decision can be handed over. Like for instance, artificial intelligence. We had in IIT Madras a recent seminar on control system being totally given it to AI. You know very well, AI is thrilling all of us in terms of our personal phones, trying to intuitively tell you what exactly the next step. And we used to get amazed that what amount of knowledge that AI has got. However, that particular seminar concluded AI cannot replace human being, particularly in a control system. You must be wondering that how well-educated professors from all over the world trying to come to this conclusion. Because once we say software is going to take control of things, and when you ask a software quality assurance engineer, he will say there is nothing called perfect software. Always the error is there, and the error is tending to go to zero exponentially, and in an asymptotic form for a long time it is going to exist. As long as that uncertainty is there, there is going to be a small error. We need to have a man in the loop to have the final, say in it. Why the man is better? Probably the brain got developed, and maturity level over the centuries or maybe over the millions of years it got developed, and that's the reason maybe better. Or otherwise, we presume that's the best way to do. We don't believe machine is doing the right thing. In the case of LCA, which is done and designed by Aeronautical Development Authority, which comes under the Department of Defense R&D, we have included good amount of decision making within the cockpit itself, cockpit computation itself. The reason being, one simple example is for a ski jumping, that is from aircraft carrier, the takeoff, the type of inputs that the pilot has to give, instant to instant, is so much of computation involved. It'll be better to leave it to the computers, and we've done it, and it is absolutely not a problem. It works very well. But at the same time, we don't trust the same computers for landing. We still have a control ourselves. Like for instance, the case of AEW in Sierra Netra, where I was the chief designer, for quite some time we have been, trying to look at the, battlefield scenario. In the sense, you have got, let us say, about 3 or 4 fighters readily available, and maybe one intruder is coming from elsewhere, who's your enemy, and you need to attack him. Out of the 3, which is the best optimum solution? It is always possible to say that the nearest one, but it has been thought over a long, process, and then found that there are umpteen possibilities are there. One is that an aircraft which is closer may not be having sufficient fuel, or it may not have weapons that is carried by that, will not have a capability to have a sure kill. So there are so many iterations and possibilities, and we finally arrived at least about 64 combinations can be looked at it. And in all these cases, human beings sitting as an operator cannot guide the pilot, which is who is sitting in the fighter aircraft, so easily by only human interferences. However, even though all the 64 solutions are made out by the computer, it is presented to the operator to choose the best possible himself. So it is not necessarily all the time left to the computation. So when it happens all in digital domain, still there is going to be a sort of uncertainties. Why I'm trying to tell this is, in Industry 4.0, we are going to have more and more digitization. Obviously, there's a feeling that it can be computed and left to the computer for even for a decision. Maybe that's one of the hesitation. Lots of people may not be willing to accept it. Even a simple, car, if you look at it, while you are driving, you would like to see the speedometer in an analog form, not in the digital form. So the presentation, acceptation in terms of user is also another, could be an issue. And in the case of LCA, if you look at it, it is unstably stable aircraft. The type of reaction that it can do is very, very fast. So there is a human input, and there is a requirement from the system, and there is a computation involved. So the computation is not small. So when you look at the feel for flying it, it so happened that in 2017 in the air show, I saw to it that many people are able to fly, because I took a decision that it's better that we allow many popular or a common person to fly in the aircraft, so that the attachment or the feeling for the system will become more, and thereby the acceptance of the LCA itself will come. So we are very happy to see that now it is accepted. The point what I'm trying to tell is, I also had a chance to fly in this aircraft for quite some time, and it was very nice to have a beautiful feeling. At the same time, when we try to control it using the stick, you will not get the response instantaneously. There is a lag between what you give as an input and the output. So this type of lag sometime can lead to some accident. Inadvertently, we'll try to go in the other direction more or something like that. So even for veteran pilots, after having enough of training, it used to be one of the nightmare. That's why they keep going to the training again and again. So now we have a system wherein that we are trying to bring in Industry 4.0. It has got enormous amount of advantages, but there are some teething troubles will be there. In addition to that, if you are looking at the defense, there is always a sort of unwritten rule, certain information cannot be shared. Like in case you are going to use a distributed computing or maybe a cloud computation, your information is there almost everywhere. So what exactly can happen could be a question mark. So the user will put a break on our developments. So in all these things, we have to have our own thinking. And so there are many challenges, certainly is there, and the opportunities are immense. So let me now look upon my first panelist, Dr. Rajendran. You have got a vast experience in integrating systems, and as a COO in UCAL, you have done many things. Your perspective in terms of what could be the way that we integrate different mindset of the people, from the operator to the user, how do you do that? And also the other difficulties, how you would have probably involved yourself in integrating them to get in Industry 4.0. Can you take some time, say about 6 to 7 minutes or 8 minutes to explain this?
Thank you, Dr. Christopher. I would like to share experience in LCA design and development manufacture. So as you all know that in the 80s and early 90s where the LCA Tejas was designed, and it was designed in IBM mainframe with CATIA as the main design software. And during that time, we have deployed manufacturing to make own winter, both high speed and low speed. To manufacture those components, the process plans were to develop the production documents to manufacture them. So in those days, we never had any application software for developing the process plans automatically. So we need to develop ourselves a software application to develop process plans. And we developed that process application software on IBM in DB2 RDBMS environment. And we were successfully able to generate process plan sequence of operations for every component. And from that, we were able to actually generate the entire production documentation called root card, progress card, operation-wise process plans, MR for collecting material from the raw material store for making these components, all those details. Then all the machine components, anyway, we had NC with 3D models, we could develop NC software. NC using the NC, and using those software, we need to validate those software usability of that. At that time, we never had anything called NC verifier, so we have to develop a software ourselves, and with a simulation system which simulated the entire machine tool, fixturing the entire machining environment, through which we were able to generate the software which could actually able to validate the CNC programs, and that was used for machining their components. Coming to sheet metal components, we had 3D models. From there, components had 3D models. From there, we have to actually generate the flat patterns. In those days, we never had an application for flattening the 3D models. So first level, we need to do flattening of these 3D models. After the development shapes are brought, we have developed a software called CAFPAD. Then we nested all these flat patterns in standard sheets which are used for manufacturing in aircraft industry. The sizes could be 4 feet by 6 feet sheets or 6 feet by 8 feet sheets. We have nested these blanks, and subsequently they need to be, all the nested patterns have to be routed. So we developed a CARIF as a software which automatically generated the CNC routing software. So that way we had, for sheet metal manufacturing, we had a very integrated solution using these three softwares developed by us called CAFPAD, CANES, and CARIF. Coming to the components which were made out of composites, so we have to again develop the from 3D model flat shapes, and from there all the pre-bricks had to be trimmed to the required lengths, and they need to be laid up. So we also developed a software for that doing, and it was done by another group. So as far as the assembly is concerned, we were able to generate a software, application software, which was actually detailing all the detailed components which go into every sub-assembly, and what are the bought out items which go along with that. We were able to generate as a production document, and that much we were able to actually do. And this software was actually to that extent was useful. But more than that, we couldn't do much on assembly area. So we had all the design workstations. They were all a LAN called a design LAN. Similarly, the CNC manufacturing machines were also interconnected, and we call them as shop floor LAN. So the design LAN and software LAN, we were able to link them, integrate them through a coaxial cable. In those days, fiber optics were not available in the 80s. So we also, for communicating between them, we have used a protocol called TCP/IP. Through that, we were able to communicate them. So for developing all these application software tools for manufacturing, so I was awarded the best scientist of the country in 1994. And anyway, but what we could not integrate was that the vendors who are supplying the raw materials from outside, the components were manufactured outside, and also the systems which were bought out, those vendors we were not able to integrate into the total environment, but also the customer. So if we were able to integrate all these physical systems, including vendors and the customers, and this environment, and they were able to communicate between themselves, and on real time, we were able to collect enough on real time data, and this data needs to be analyzed, and then we should be able to visualize them. And using some algorithms, if we are able to take decisions, and then those decisions need to put back into the physical systems to correct them, whatever need to be, so that this entire environment is nothing but Industry 4.0. So if you want to define what is Industry 4.0, in my opinion, the integration of all physical with digital to achieve the organizational goals or objectives. That is exactly what Industry 4.0 is all about. And why Industry 4.0? What does it benefit us? Industry 4.0 will give us, as we can see that it reduces the cycle time. There is a better operational efficiency possible to achieve, better utilization of every resources we have on the shop floor and elsewhere. We are able to, once we reduce the time, which means it is a reduction in cost, there is a better quality possible to achieve. And this brings in, there is a robust system which has been deployed for manufacturing products, so which means there is enormous confidence level for the customer to use these products. So that's, we can become globally very competitive. So what does it mean? What kind of technologies need to go into this to really realize Industry 4.0? So in my opinion, additive manufacturing is one important tool. Today, additive manufacturing, I understand that nearly 78% of additive manufactured components go directly into the aircraft. And this also, the technology is very useful for prototyping and also making tools. So we need to have advanced analytics because there is a real-time data, huge data comes in, and this needs to be analyzed and visualized. We also need to able to actually using algorithms make decisions on this. So we need to have some artificial intelligence required, and then we need to have advanced robotics for assembly operations, doing robo riveting, robo painting, things like that, and maybe pick and place robots in the CNC shop floors. We also need to have a lot of blockchain technology into that, because that is where it gives you better just-in logics, particularly all the real-time data when we collect. So we need to have the VR tools and AR to augmented and virtual reality tools, because these things will definitely make displaying of all the information, the shop floor information, both at manufacturing level and also at assembly level on smart glasses. So this technology is important, and if we have to integrate the people from vendors and customers, etc., then we need to have IoT technologies also need to be implemented, so that we will have a better integrated solution for that. So that's, I think, Industry 4.0 is a very critical technology which is required, that if we really want to make in India very successful, we need to look at adoption of Industry 4.0 by all our industries across the country and to become globally competitive. Thank you.
Thank you, Dr. Rajendra. It's a nice presentation, and I would like to tell you that you almost started your 4.0 way back in 1980 itself, and
Yes.
I'm happy to see that it was in LCR Tejas program, and which we are all part and parcel of it, and we are proud of the achievements what has happened. Having said that, what do you think is the status today? Because you all have started very early time. If you say Industry 4.0, what exactly is the status in the country, particularly for India? Because we are now trying to do the Atmanirbhar and so many other things. We have to bring in more and more technology transformation. So will you please tell what is the status?
Yeah, actually, if you really look at this Industry 4.0, what is really happening today, in my opinion, that the large industries, both in government sector as well as in private sector, they all have utilized Industry 4.0 to a reasonable extent. But if you, I recently heard that HAL is also planning now to have a jigless assembly and having AGVs for automated guided vehicles for components from the tool stores and bringing it to the assembly area, into the jigless assembly area, using robots for assembly, all that, So these things happen in the large industry, government as well as private sector. But if you take about large MSME sectors, medium and small scale industries, of course, this technology still in a very early stage. And why is it so? If you really look at it, I think it is basically lack of know-how. There's no proper infrastructure for learning these technologies. And these technologies definitely demand very high. These MSME sectors have difficulties to actually bring in. And also, employees, that is, technicians need to be differently skilled. That infrastructure again is required. And also, today, once we have the Industry 4.0 integrated, we need to have cyber laws very effectively. Otherwise, there could be issues because of this. So these are all the kind of lack of. As far as Industry 4.0 is concerned, I think, in my opinion, we are still MSME sectors here in a very nascent level. That's what is my feeling.
Dr. Christopher, I think you're on mute.
Yeah, what exactly? I mean, you probably answered what I was about to ask the next question. It is in terms of how do we speed up, the Industry 4.0. I understand from you there are some laws need to be included or introduced, which will enable certain things. Do you have any more points on that?
Absolutely. I think the way forward, literally, if you look at it, in my opinion, that of course we have to bring in, have the infrastructure in such a way that we should be able to actually bring this know-how across the industry, even to the very small industries and medium scale industries. This knowledge of Industry 4.0 has to be widely spread across the country. That is the first requirement to navigate. The second important thing is that we have to reskill the people, educate the employees, to actually bring in new technologies. This is what is need to be done. And then probably the best way to go is Industry 4.0 is to start adopting additive manufacturing technologies, progressively in the small scale and medium scale industries. For that, I think there should be some navigation. Probably there should be intervening from the government to see that some soft loans or some. If you take Ireland and Indonesia, they are all giving a lot of impetus for Industry 4.0 to be implemented there in those countries. As we all know that Japan is far ahead, and of course Europe, but even Chinese have a huge programs actually to bring in Industry 4.0 into their country. So I think we need to have some government mechanisms to bring in some kind of a promotional thing, so that the industry can quickly adapt into the Industry 4.0. We need to bring in reskilling infrastructure. All these facilities should be available, like our skill development, what we did in the early stages. We need to suit into the Industry 4.0 environment. So unless we really do all this, the Make in India program will have no, really if we want to be successful, we have to give impetus to Industry 4.0, and that is how we can really become global.
Thank you, Doctor. Thank you, Dr. Vijay.
Thank you.
Yeah. Mr. Nikhil Joshi, being head of EAT in India, Bangalore plant, I'm sure you would have implemented already. If not, I would have at least started it. So, would you like to share what are the challenges probably that you have come across while implementing this in your own industry?
Sure. Thanks, Dr. Christopher. It's funny that you started with a question on challenges, because frankly, when we opened this is a greenfield facility manufacturing fluid conveyance products for the aerospace industry. And these products are, they are typically low volume, high mix, high value products. There is a lot of customization involved. There is a lot of stringent quality standards that need to be ensured, like for any aerospace product. So the challenges, I think, as far as deployment of Industry 4.0, the first challenge was a lack of clear understanding of what exactly Industry 4.0 is in the first place. In many cases, a lot of us are, struggling to actually come up to Industry 3.0 standards, which essentially brought in automation to the manufacturing sector. Now we are looking at Industry 4.0, which goes beyond automation, but it does not presume or assume automation to be in place. It does not require automation to be in place. It is a common misunderstanding, I think, that automation is a prerequisite for Industry 4.0. Industry 4.0 is a collection of technologies, tools, and processes which bring the cyber and physical world together. And leveraging those technologies and tools can lead to immediate benefits in productivity, quality, even safety for that matter. But like I said, there is a common misunderstanding that automation is required. And in an industry or in a manufacturing setup like ours, where there was this huge product mix, where it wasn't a assembly line kind of an operation, it became difficult to automate, and therefore it was thought that Industry 4.0 cannot be effectively deployed. That was the first challenge, getting around to a clear understanding of what Industry 4.0 is. Second was to identify what is to be done and where it is to be applied. Because the what question really, when you look outside, there is a huge buffet of Industry 4.0 technologies or offerings that are available. Unfortunately, there is no one size fits all. You can't go to, a firm that makes an Industry 4.0 application and say that just buy it off the shelf like Microsoft Windows, for example, and deploy it at your plant. It just cannot be done, or it cannot be done effectively at least. If you do that, probably the returns on your investment are not going to be worth the while. So identification of what the value driver is, where the maximum benefit can be realized, is critical. Once you do that, I think, and that becomes difficult, because the technologies are so new, you're not familiar with the benefits or familiar with the opportunities that exist. It becomes very difficult to apply the what and where. Now, what is to be applied and to which part of your operation can it be most beneficially applied? So I think those were the main planning challenges, I would say, as far as the deployment of Industry 4.0 was. Once we actually determined those, got past those hurdles, did a lot of brainstorming, learning from the industry, learning from our peers, learning from our competitors even, I think the next biggest challenge, and I think this is common across the industry, whenever you talk about aggregation or integration of the cyber and physical world, security becomes a big question. Physical security is something that we have all got used to maintaining very effectively in the industry. Cyber security still is an unorganized part which we are struggling to cope up with, and our way to cope with that is restricting data. And that is contrary to Industry 4.0's requirement, which requires data openness to an extent. Because you collect data on scale and use that data to drive effective decision making, the restriction in data availability or data sharing becomes a concern. So security is the next big challenge, I think, that we faced and this is specifically true when you're dealing with, ITAR regulations, for example, whether trade regulations, whether industry regulations, the customer requirements to restrict data flow and data sharing. So those were the really the main challenges in deploying Industry 4.0 in a manufacturing. And I don't want to generalize these. In general, they're very similar to what I've seen outside, but these were very specifically to our manufacturing setup. So I can't hear you. I don't know if you're on mute.
Thank you, Nikhil. Basically, do you have a specific method of choosing the process? Because you said there is no single solution, but still somebody new has to find a way. Is there any method evolved or it is existing?
There are, I think, a number of methodologies, I think, existing by various firms, organizations, consulting companies, etc. The one really which I found very simple was, it's called variously the digital compass. I think it was originally developed by McKinsey, but it is being used by various agencies as well. It's a very quick, way to assess which are the value drivers. Essentially, it looks upon 8 value drivers for Industry 4.0, and then there are various levers associated with this. Those value drivers which you can then apply, and those levers are the processes, technologies, and systems that Industry 4.0 consists of. So of the 8 value drivers, I think, when we started brainstorming, we realized that given our products, given our processes, we needed to concentrate on labor, inventories, quality, and to an extent asset utilization and resources and processes. These were our main focus areas as far as deployment of Industry 4.0 is concerned. And the levers that can be applied then lend itself to logic and to where within that you can derive the maximum benefits. Typically, if you look at asset utilization, you can actually achieve about 30 to 40% reduction of downtimes as far as equipment is concerned, just by monitoring it in real time, by doing predictive maintenance instead of total preventive or planned preventive maintenance. You can actually achieve those kind of cost reductions and productivity enhancements. Even in the labor front, by deploying these technologies, you can achieve up to 40 to 50% increase in productivity. So we looked at these areas where our production was labor dependent, or where, like Dr. Gajendran said, the cycle times were higher, which could be reduced, not because of automation. Automation was difficult to employ or deploy in our manufacturing setup, but by just putting in systems to capture data in real time, to record that data, to ensure transparency, and to ensure it fed into the quality system as required, because we realized the operator doing the job was not consuming as much time as it was for him to measure data points, measure parameters, and record them for future use. So those were the typical areas where we concentrate upon, where maximum value could be derived. And the investments are high. Industry 4.0 is something that we are seeing costs drop by the year literally. But having said that, the costs are high because even though the cost of the application may not be that high, it requires a technology stack that it relies upon in the background. It requires connectivity, it requires machines to talk to each other, it requires security layers that I discussed earlier, and all of that costs money. So you need to be able to focus your attention on specific areas that give you value, that drive productivity increases, because productivity increases is the quickest win that you can achieve through a deployment of Industry 4.0.
Sure. I understand from your talk that one of the challenge that you have is security of data. But we understand generally in the case of defense, the data security is one of the prime. Whereas in a normal industry, do you feel the raw data collected in millions of points is really to be secured?
It's not a question of whether it's what the customers require of you, or it's what the trade regulations permit you to use or share. Data is open to interpretation. You might assume that the data points captured from your equipment that you're using for production is really open source and can be shared. But today we know from the conversations around even Facebook and WhatsApp that very innocuous data points collected over time can give insights today that couldn't be imagined earlier. So data security is all the more important given the fact that we are collecting now data on scale, at such a huge scale.
Sure. Thank you for your insight in all these points.
Thank you,
Let me
Dr.
now
Krishna.
go on to Mr. Ravikaran. You being the Director Aerospace and Defense Systems in Dassault for quite some time, I'm sure you will be able to tell us about the best practices and the adaptation of Industry 4.0 in Dassault.
First of all, thank you very much to SAEINDIA and IDAT for giving me this opportunity. It's indeed an honor to be sharing the stage with such accomplished personalities like you, sir, Christopher, sir, Gajendran, Nikhil.
Thank you.
Thank you very much. And it was a very interesting conversation, the way Gajendran sir mentioned about how it all started in 80s. And then more or less a very contrary view that Nikhil has brought out, saying that Industry 4.0 has had its own shares of concerns from the data standpoint and all that. So it's a very interesting conversation. It's not like everybody is converging to one view and saying that, yes, everything is good and hunky-dory. That's a very good aspect of facet of this panel discussion. So I'll bring out 2 points. So one thing is Industry 4.0, as a lot of, and in fact, Nikhil said that it is not about automation and there are various ways of looking at it. A simple way of looking at Industry 4.0 is how do you transfer or transform information to insight and insight to action. Okay, and then there are all various actors in it, various technologies that play in it. But in a simple way of telling it is how do you translate information to insight, which is the concern Nikhil said, an information that is gathered over a period of time becomes an insight, and that insight to an action, so that there is improved OEE, which is important for the productivity, utilization of the resources, and secondly, improving the quality, right? And as a technology provider, Dassault Systems, I represent the software arm of Dassault. We provide the Industry 4.0 technologies. And while the adoption is reasonable in other countries, in Indian context, there are some challenges. So I'll just quickly brush through the challenges, and also I'll try to bust some myths around it. Okay. One of the challenges that we see in Indian context is lack of infrastructure. Most of our industries are still using 1940s, 1950s infrastructure. The infrastructure is still not modernized, and some machinery doesn't even have PLC controllers to say. Okay, that's one of the hindrances that is coming in the way of adopting Industry 4.0. Okay, and also lack of digital adoption. Okay, In many organizations, even the computers, laptops are not given that. Only few executives have that access. It doesn't translate to shop floor means it's only machines and tools and nuts and bolts. But computer is a far-fetched idea to have a computer in a shop floor, right? And Industry 4.0 begins there. So see, this is the kind of very interesting dilemma that we have. So that's one of the challenges, and I see, sir, it as more of a mindset uh, than um, than having cost as a reason, because now we know, and that's where I come to bust the myths that hardware costs have dropped down significantly in last 10 years. Now sensors and actuators and PLC controllers are commodities. You can get them for probably lesser than some of the other things that you think very easy to buy. So that's one myth that I would like to bust, that the cost from the hardware standpoint is not at all a hindrance or a concern if the mindset can be adapted that way. And from the networking standpoint, a lot of people say India doesn't have the networking speeds, because Industry 4.0 is all about connection. What about that? Now I think 4G, 5G revolutions, even a small roadside rickshawala has a 100 MB data, 200 MB data, right? And the data access, the data provision has substantially increased in the last 5 years. So that's another myth that we can bust and say that things have changed significantly from hardware and networking standpoint. They're all affordable. It's how we see it and how we embrace it. That's the question, and that's where the leadership comes into picture. I strongly urge the leadership, the visionary leadership, sir. I know we want visionary leaders like you who can advise the industry, tell the industry that there are ways to look at. There are challenges, and that we will not have a overnight transformation. Like, we will not become a Germany kind of a country overnight. But there are steps to take. There are small steps that we can certainly take in getting there. So how do I see it? And this is the right time. The opportunity in front of us is the right time, because there is a thrust on Atmanirbhar Bharat. Okay, there is a lot of thrust on indigenization, having local production. That means there is a business, unlike an automotive industry, which is built to stock, right? You can stock it and then you can sell it. Aerospace industry is built to order, right? Orders drive the business. Without business, you wouldn't want to adopt technology. You wouldn't want Industry 4.0 because there is a cost to it. So now it's a good time, because as early as last week, we have heard about a phenomenal news that industry is getting an order of 48,000 crores, and that can percolate downwards, that can transcend downwards to the entire ecosystem to get benefits out of it. That will encourage the adoption. And secondly, uh, earlier the foreign collaboration was more of defense offsets. Okay, Lockheed Martin has come, Airbus has come. Most of them are looked at defense offsets, and they were also creating joint ventures only to get the business rather than the interest of having to create a local supply base. But Industry 4.0 can really improve the quality. I think people should look at us not because we are giving them the business, but they should look at us because we are delivering quality, right? And that's where Industry 4.0 will immensely help the Indian industry to deliver the quality. And there are another questions, I said, what you asked is what are the best practices that one should adopt. Is, I think I like the point of Nikhil, where he said pick the areas where the the return on investment is high. Okay, and by adopting Industry 4.0, the benefits are larger as compared to the investments. For example, if I have to say it on the shop floor, okay, I'm not talking about put cameras, put sensors, put completely automated, but at least ensure that look at your uptime of the assets, your asset uptime. That's a very basic way to look at it. I'm not even talking about data analytics, intelligence, and all of that. How do you ensure asset uptime is probably having these ways and means to capture the data that is coming from the machines, which is now can be retrofitted with PLC controllers. It's a very less cost-effective method. Get that machine's data, see whether they are running on time or not, see if they are going to break down anytime soon. Have that predictive maintenance methodologies so that your asset uptime is ensured. a production entity is as good as its assets. If their assets are functioning, I'm sure I don't think any challenge with other aspects. People will deliver, and we will see a more productive outputs. And that's one place where we should look at Industry 4.0, asset uptime, getting assets deliver the OEE to its fullest, and secondly, quality. And quality, when I say quality, sir, quality has a lot of interpretations, right? We are good. Sometimes people misinterpret it, saying that what's wrong with Indian quality? We are good with quality. It's not that we are bad, but there are some methods in terms of process adoption, like Pokayoki. Whenever there errors are part of life, they happen. But how fast are we identifying them? By putting simple Industry 4.0 techniques, and that brings in the process adherence, that brings in this Pokayoki, that error identification at the very beginning stage, not at a very later stage, right? And that saves a lot of time, a lot of rework, a lot of scrap, a lot of cost. I can tell you simple things that we do in the fabrication layer and the production layer can enormously affect the overall cost of the delivery and the quality. And this Pokayoki. So in short, I'll put 2 points forward in terms of the best practices. Look at adopting Industry 4.0 in ensuring the asset uptime. That could be predictive maintenance techniques. Very simple, without having to invest too much into the modernization. Simple actuators, sensors, and PLC controllers, which are more or less commoditized now. One. Point two, bring in the quality adherence by deploying some of the digital layers, digital continuity layers that will ensure Pokayoki that is enforced. It's an enforced Pokayoki. It's not based on people. It's not based on the organization. It's based on the technology that enforces that Pokayoki measures so that the quality is improved. And what are the outcomes of it? When the quality is improved, the foreign collaborators should come here not because of the business that the Indian government is giving, but because of the quality that we are delivering. That's one key outcome. And then this is the right time. As I said, hardware networking, these costs are not hindrances anymore. And Atmanirbhar Bharat is a great opportunity. National manufacturing policy is a great policy. There are some good initiatives, but it's all in the hands of the visionary leaders and the industry to adopt and implement them.
Thank you, Mr. Ravikaran. Nicely and vividly put it across that how our industry sometimes not looking at laptop as a sort of a tool rather than looking at it as a luxury. At the same time, if we bring in quality, I'm sure we will be able to attract more and more foreign companies to come and use us. That's the point. There are so many topics associated with I 4.0. What do you think is the way that somebody like a very small company, MSMEs, would like to jump into, let's say, start, and what the way they should start? I mean, is there any thumb rules? Implementation of Industry 4.0.
Good afternoon, everyone. Actually, I'm really on the other side. In fact, our company, we actually work with the industries to implement Industry 4.0. I would say with medium-sized and smaller companies. So we are, in fact, it's very interesting to hear all of you talk about both the pros and cons of what is happening in India in terms of Industry 4.0. And taking on from some of the points which Ravi mentioned, yes, I think one is there's a lot of reluctance from the industry in terms of investments because aerospace and defense, the business levels are yet to pick up, and it's not a predictable business, so there's always reluctance. Cost of money is still high in India, so I think there's always a reluctance to invest upfront. And that apart, in terms of, I'm also from the electronic industry, so when we look at Industry 4.0 implementation, especially in the aerospace and defense, you look at the automotive industry. Now, all of you have had enormous experience in the industry. Industry 4.0 efforts, they are a lot driven by the customers. See, today traceability is a must when you supply anything to a auto major, right? So you have no choice. But in terms of the aerospace industry, it's really strange because aerospace and defense actually traditionally have a lot of very robust systems. They have their own systems, and you'll have to fulfill that. For example, some of the systems we also are in that business. We make some equipment for defense. When we make, our documentation size is a lot bigger than the equipment size. We deliver tons of documentation, but they're all in the way which were the systems are drawn up maybe 40, 50 years back. So we say everyone completely follows exactly the same, and then there's neither an effort to simplify the system to ensure that they are I would say in line with today's technology developments. So with the result, what happens is that they are generally digitization is a bit slow in aerospace and defense industry. I think this was discussed in terms of worries about safety of the information, worries about hacking. So there's always, in fact, interestingly, we did one project for one of the defense industries in which we had to connect their 40 key suppliers so they can actually monitor online in terms of their performance, because they found that most of their production peaked only during the last 2 months of the year, which was crazy. So they wanted a system where they could monitor online their key suppliers. Now, it was a huge effort and a lot of confusion because they did not want the information connectivity between the suppliers and their ERP. So their ERP had to be isolated from this information. So we had to create a specific center where the center will connect to all their suppliers. And then people will come and enter manually the ERP information. The people in that unit will come and manually enter, and then take that information, and then take this information back and feed it to the ERP manual. Now, these are some of the real life issues in the defense industry for implementing this. Although the kind of systems they have, if they, I would say, streamline it and take it in line with Industry 4.0, there will be enormous savings from both the defense and the suppliers. For example, C4I. C4I is such a sophisticated, end-to-end, I would say, activity which is being, Indian defense is starting to adopt C4I. C4I will require really a very good Industry 4.0 kind of implementation for them to make it work very well. Now we are talking about, soldier as a system. It's really Industry 4.0 to get the soldier interconnected with the brigade headquarters and to the headquarters. The thought process is there. But in terms of implementation, there are probably a lot of delays because maybe the investments and maybe the always a hesitation in terms of information sharing and providing. I think these are some of the things which kind of, sir, you at your level have to really kind of work with and advise them. But from the manufacturer side, because of in many of these issues, there is no match in terms of how a manufacturer would like to structure his system to the actual user. So, like in the auto industry, if the aerospace defense industry kind of align their requirements to the systems, then it will work very well. I mean, then people will have no choice. Even small industries will have to really fall in line and like in the auto industry, they will have to start implementing Industry 4.0 in a good way. I mean, they will have no real choice. Then the other point is that it's also brought out, the thing is, there's a lot of, I would say, myths around, and I think Ravi also mentioned a lot of myths around, in terms of the Industry 4.0. Everyone thinks that Industry 4.0 is something so big that small guys, it's very difficult to attempt, so let's postpone it. I think one can start step by step. They can start with, this is also discussed, start with digitizing or picking up information, some of the machines, and then, understand how the machines work, then save, in terms of the OEs and production. And the other important thing for anybody, whether small or big, is preventive maintenance. So Industry 4.0 techniques can be easily used for preventive maintenance, and that's going to save enormous costs. Of course, in the services, preventive maintenance, if they use these techniques, that's going to save them probably hundreds of crores a year, I guess, because that's going to be very helpful for them to understand and work on maintenance quickly. But for any industry, preventive maintenance is going to be I would say, a quick return on their investment in this area. And then, of course, the OEE and things like that will be a great return. The question is, one feels that it is like the time when the bank started implementing, computerization. Everybody said that's too expensive, cannot be done. Like Ravi was saying, it'll throw away all the jobs, so we cannot do it. In fact, the bank employees went on strike. But today, can you imagine a banking system working without computerization? It's simply, I mean, people don't even know that people went on strike on this issue. So I think Industry 4.0 is a technology on the same lines. It is going to give enormous advantages to whether industries, whether they're small or big. And it's a question is, you bite the bullet and start in a method where you go step by step rather than trying to go. See, what happens is you read a McKinsey report and it looks so complex because they have a big chart which shows that you have there are 15 elements to Industry 4.0, and those 15 elements are 1 by 1, 2, 3, 4. And then you have to kind of integrate all of them to get all the benefits. So I think it is not really the case, and you can take each one of them and then work one by one, and then definitely get enormous benefits. I think think small and grow, and that would be the way. I mean, I would recommend the Indian industry to start and then get a lot of benefits out of this. So I think techniques are many. I mean, you can have robotics. For example, we are trying to. We were also in our industry. We have a robotic group and the AGV group. When we start talking, when you say robo, the medium scale industries or small industries, they balk. They say no. We don't want all these expensive tools, and we have labor which are low cost. So we try to really address the issue of your quality levels and the precision which you will get. Aerospace and defense, the precision levels demanded are critical. So you cannot compromise on this. So we work with them to show payback, which are definitely profitable when you start looking at those things. So it's a difficult road to convince them, but the returns are there, and then the returns are really significant. Job, I think, Ravi, maybe I'll take a slightly different view. I think a lot of these concepts in short term may dislocate jobs. Definitely, you go and start working on robotics and AGVs, you definitely will replace some of those people, but they have to be reskilled and work on it. We can't say that, as I mentioned earlier, bank employees cannot say that we'll go on a strike because you can't have computerization. Okay, that's basic to and efficiency and reliability. So, an Industry 4.0 concepts are basic to efficiency and reliability. They have to come in. They may replace jobs, but the managements have to acknowledge that, saying that, hey, if I introduce 10 robots, I'm going to replace from that spot maybe 30 workers, but I am going to train them to do these tasks which are better, and as Ravi said, which are in fact a lot less repetitive, and it will be a lot more in terms of an acceptable kind of job. I think it's the onus is on the management also to sell the idea of Industry 4.0 to their employees, and then skill them, and so the transition is a lot, I would say, smoother and more productive. That would be my comment. Sir. Sir, I think you are muted.
Sorry, and unfortunately, to make the noise less, I keep doing it and myself forget. Thank you very much for your wonderful talk on this, all the concerns and whatever we have on this Industry 4.0. One thing what you said is the robots are not liked by many people, particularly small companies. One is that it could be a feeling that costlier or a cheap labor is available. Why not the fear that not performing autonomous robo can make much more damage to the system? Is there any thought process on that?
Sir, now there is the robots also are evolving, and we have now collaborative robots. These cobots can work with people. You don't need a fence. They work with people. So some of the difficult jobs, where physically difficult jobs, you can assign to the cobots in a line, and the employee can work along with it. The cobots will say heavy stuff, they'll bring and put it on your table. Then you do some work, and then the cobots then add some work, take it, place it elsewhere. Oh, it's a lot of conveniences are now available in technology. Cobots are, really a very nice invention. You don't need actually a fence. You don't need to protect them. And then when you touch it, it will stop. It's very safe to work along with it. So robots are today, very convenient. There are no issues. You don't have to worry about it at all.
I'm all the more afraid that it might replace all of us.
No, okay. That's probably I would say a century away, I guess.
That's right. That's right. Okay. So you also said there are communication links sometimes in order to ensure the data security, physical and digital media. We always have a fear what is getting leaked. You think it is a big problem, or is it solvable?
No, it is solvable by technology, but still there are. See, today hacking has become a massive industry. I was quite shocked to read last week that I understand that the hacking is a $2 trillion industry. I mean, that number is so big to really even believe that. So it is a problem. In fact, they even hacked the Pentagon. So I think the thing is, this is certainly an issue, but today, what's happening today is the A&D industry or any industry, they have to keep their mind open to invest in measures of protecting your communication and the data. I think this realization was not there till recently. So now we have, of course, ISO approvals and stuff, but I think it's periodically. For example, we are a small industry, but once a year we get ethical hackers to hack our system to understand whether the system is safe or not. And maybe A&D industry has to do it more often. So I think there is technology, you have to live with the technology, but you have to take appropriate measures to protect your technology. And also, I guess in the West they have perfected this. They generally go on a basis of need to know. But in India, that system, does not. Indian companies, maybe MNCs have that Indian companies, the information is available very freely. I think maybe we have to really mentally change to have systems which are only on need-to-know basis internally as well as externally, and then have protection for your data security and communication. You have to live with it.
Thank you, Ramchandran. What exactly you said is right. The need to know. In the event that you have something which you need not have to have, the policy should be so strong to condone that. That's the reason why we are slightly more liberal. Unfortunately, when we don't know its seriousness. Obviously, it gets leaked to elsewhere. I would like to thank all the panelists for a wonderful talk, and we have really brought many things to the audience. One is that I find that the government policy and the decision making must be there in order to promote Industry 4.0. Unless otherwise you bring certain things to the common man, I don't think they will be able to pick it up and go along with the Industry 4.0 as we anticipated the speed. Industry 4.0 implementation also be costlier for the individuals, so we may have to have government-owned or special centers to start it, and then in a long run it will give a payoff or dividend not only to the country but also to the individual, because they will fall in love with that and go along with that. The Industry 4.0 as of now, to larger extent, probably is started in a big companies and in a very big companies, but not necessarily it is in MSMEs. But the fundamental need is that we must have in MSMEs, this must be there. The job opportunity is not taken away, but it is shifted elsewhere. In other words, need not be having the same job, more number of people, but there could be a different type of job opportunity may come. And data security is one of the big challenge for all of us, whether it is a secret defense information, or for a company secret, it has to be really kept, or even a trivial information over a period collected, it can have an insight into very, very many things. So it has to be brought in as a law to control it. The mindset of all the people should change, particularly having a computer or a laptop right in the workshop and the shop floor must be thought as a normal way of working. And there is no unique solution for any of this implementation. It needs to get adapted according to the need. Ultimately, the Indian aerospace manufacturing industry status is, as far as the I4 is concerned, is excellent or good in big companies and should be percolated to MSMEs in case we would like our Atmanirbhar Bharat to be implemented as effectively as possible. Thank you very much.
Thank you, panel members. I think it was a good discussion. Team, any questions on the chat box? We are just checking the chat box offline. No hands raised. Anyone would like to ask questions to Dr. Christopher, Dr. Gajendran, or any of the panelists, Mr. Ramachandran?
Yeah, I have one question.
Yes, please go ahead.
Yeah, can you hear me well?
Yes.
Yes. So, this question is actually for Mr. Ramchandran and anybody else who would like to take it on. So, what I understood is that the automobile industry has been implementing Industry 4.0. Can we have some examples of that? Of that?
Sorry, was the question addressed to me?
Yes, yeah, because I heard you say, sir, that while the aerospace and defense industries may have challenges, there have been such implementations of Industry 4.0 in the automotive industry.
Yes.
Can we have details of one or two cases? So
Yeah, I can give you an example. For example, see, your digitization and traceability in auto industry is now a standard. For example, if you're a supplier to any one of the auto majors, you have to have a system where your data and machine data is all digitized, and then your traceability is well established. It's compulsory. So even if you're a smaller supplier, you will be required to provide that information and connect it to their information system. So it automatically, all the suppliers, they have an incentive to do this.
Okay.
In the A&D industry, that's while there are good systems, but this kind of a compulsory link up is not there.
Okay, I'm sorry if I can ask a supplementary question. We work mainly with the inspection industry, non-destructive testing largely.
Right.
I find that the uptake of digital inspection technologies, I think India probably is on the lower side right. So there is actually a direct contradiction between the focus on Industry 4.0, whereas a lot of the inspection methodologies are still from Industry 1.0. Right? So unless we are able to move up this chain, and that includes the automotive industry as well. I see a lot of use of X-ray film, as well as surface techniques that are not digital yet, right? So that is there's a significant disconnect between what we are stating and actual practices in the industry.
I totally agree with you, Christopher. Here, I totally agree with you. I was trying to bring in this type of digital inspection, even in DRDO, and there is a lot of hesitation. Some of the people said there's a lot of secret information will go, and some people said no, the conventional way of method measuring and having the years of data will get lost. Can you imagine an object designed in a 3D was ultimately translated into 2D drawings only for the sake of inspection, which was the really precarious state. So I tried my best to change, and as a matter of fact, in Pune there is a company, I think Accurate. We talked to them. I visited them and found that there are a lot many advantages in that. Thereby, I created within DRDO, I created a system by which centrally we hired some people. Of course, in a global tender or open tender, I don't think that Accurate came in, but otherwise, we created a system by which all information, whichever is not, of course, very, very secured information, is always collected and kept in the central place that I implemented. But what he said is true. There are a lot of hesitation in that area.
Thank you.
This is Dr. Gajendran. Hello.
Yes, sir. Yes.
You are able to hear me?
Yes, we can hear you, sir.
Yeah, during the LCA design and development, we also developed an inspection software where we were able to actually, from CAD model, able to pick up inspection points, and that was able to generate a software or a program which was able to touch upon on the machined components or the sheet metal components, those specific points of inspection, and through which we are able to generate a sequence of touch points by a probe. And this software was generated, and we have processed to a CMM control system. And we loaded this software into CMM controller, and the component was loaded on the CMM bed, and put a Reneshaw probe as a touch probe, and through which we were able to generate the actual machined component measurement on those specific probe points, and compare it with the theoretical or the design data from the CAD model, and put up a variance between the design points as well as the actual component measurement. And this variation, whether they are within the tolerance or otherwise, was decided by a printout, and an inspector could look at this printout. Based on that, he was able to actually decide whether this component is acceptable or not. So this kind of a simple inspection software we could do it in early 1990s itself. We could implement that, but it also needs a lot more kind of algorithms which could be developed, wherein the inspection can be done a lot more automated way. But what we have done, we could in a small way we were able to implement and reduce the inspection time substantially, and also had a printout which could substantiate why did we accept this particular part, so that whenever there was a traceability requirement is there, we had a document that why this component was acceptable. Thank you.
So, Dr. Christopher, we are actually overshot the time.
That's true.
Quite dearly, but it was a great discussion. We keep getting the comments in the chat box. Is it okay if we can close the panel discussion?
Yeah, please close it. And if at all any interesting question is there, please pass it on. We will try and answer if possible.
Thank you, Dr. Christopher, Dr. Gajendran, Nikhil, Ravi Kiran, and Mr. Ramachandran. It was a great discussion. Thank you so much.
Thank you.
On to the valedictory.
Thank you. Thank you.
You're welcome. Thank you. We are moving on to the valedictory session of the first ever joint virtual conference between SAE India and IDAT. I thought I thought, ladies and gentlemen, it would be grossly inappropriate for me to deliver the valedictory address when so many eminent personalities of Indian aerospace industry is around. We have requested our immediate past president, Dr. Bala K. Bharadwaj, to deliver the valedictory address. With your permission, sir, if we can also request Mr. Ravi Shankar Mysore, our aerospace forum, to say a few words, maybe before or after, you can decide. And ladies and gentlemen, I would like to introduce Dr. Bala K. Bharadwaj, very well-known name.
Venki, I think let us start with Ravi Shankar.
Okay. Thank you, Dr. Dr. Bala.
Good evening, everyone. Thank you so much for.
Hey, Ravi, you deserve an introduction too.
I was about to say, and I think, Ravi, give me 2 minutes, Ravi.
I'll introduce myself, Venki. No worries.
Okay, go ahead.
Okay, great. Just to save time, so my name is Ravi Shankar Mysore. You can call me Ravi. I have over 32 years of experience in the industry. I work with various companies like L&T, Bharat Earthwas Limited, TCS, Infosys, and in the recent past with the Collins Aerospace. So my association with space industry was mainly at Infosys and Collins Aerospace. Of course, many of you may not know Collins Aerospace. It was Goodrich, it became Mutis Aerospace Systems, and recently, after merger with Rockwell Collins, it became Collins Aerospace. So I took early retirement from my job about a year ago, just before the pandemic hit. I did not know the pandemic was coming, but I still had taken it. So I have taken over as the head of the SAEINDIA Aerospace Forum. Thanks to all the members of SAEINDIA for having nominated me. Of course, I've worked very closely with Dr. Bala and Venki and Muni for the last several years. So as far as this particular session is concerned, first of all, I would like to thank all the speakers for sparing their valuable time. Eminent speakers from various companies and across disciplines having really participated actively, and specifically IDAT for partnering with SAEINDIA for this particular session. Secondly, but not the least, sincerely appreciate great participation from various participants from across again the aerospace industry. It was a great session, and look forward to having many more sessions going forward. Thank you once again.
All right. Hey,
Over to you,
thank you
Bala.
very much, Ravi. I think, Venki, let me jump in. We are half an hour late already. By way of introduction, I think I know many of you know who I am. I used to be the president of SAEINDIA until about a month ago. Just on the 22nd of December, just about 1 month ago, we had a change of guard. So now we have Rashmi Urdhvareshe, who is the current president. So I get the grand title of the past president. But the reason I'm speaking here is because I also have a lot of experience in the aerospace industry. I used to work at Boeing. I say used to because I took retirement 2-3 weeks ago, and working at Boeing, and prior to that in the university system, in the academic system, more than 40 years of experience fooling around with aerospace. So I learned a few things along the way. So I think that's my claim to fame, why I'm speaking to you. First of all, I think this was a wonderful session. I've been on the call starting from 2 o'clock, with the brief introduction from Venki, but really starting with what Shekhar had to say, and then Muni and all the panelists. I think a lot of wonderful discussion. I was actually very pleased to see some very positive stories, positive perspectives, and some caution as well. Because I think I am more on the caution side. I used to lead the Engineering and Technology Center, but over the course of my career, I've seen too many situations where we charge blindly thinking that some technology will solve something, and then we find out that human beings are human beings. They miss something. Technology doesn't solve everything for us. And the example that I think it was Dr. Christopher who talked about how the experts came together and they said, you know what, we are not going to let some artificial intelligence system control our aircraft when it is in some critical operations. For routine things we can, but when it comes to critical operations, I think our approach has to be different. So I think Industry 4.0, or where we want to go in terms of manufacturing, is no different. We have a huge variety of people, who are either doing already or interested in doing aerospace manufacturing. In the country, we heard about people who have, machines that may be decades old. And then we also have organizations that have the latest machines. But I'll tell you, having the greatest gadget, the latest software alone does not accomplish things. You need the latest gadget along with people who are knowledgeable enough, smart enough to utilize those gadgets. So I think that development has to go hand in hand. So that's something to keep in mind. The other thing that we have to remember is that aerospace, whether it is on the military side or on the commercial side, tends to be a long gestation project. Projects go on for a very long time. Many times I've had this discussion with some of you in the past. Companies are willing to say that I would like to invest if you can guarantee a certain amount of work. And the pandemic is the latest reminder to us that even a company like Airbus or Boeing is not going to simply say, go ahead and manufacture more of these, because there is no need there. The requirement is limited. It is dependent on what else is going on in the world. I think it was SM Vaidya who said, well, we are not making that much for the commercial side, but we are now making more missiles. So as long as the armies are trying to fight with each other, there's always a need for missiles. But if we are all peaceful, nobody cares about making more missiles. So this is a business that depends not on how many ads we can take out on Google or Facebook or whatever. It depends on events and activities well outside most of our ability to control. So if you want to succeed in aerospace, you have to be flexible. And we had some great examples mentioned by Dynamatics, and I think also by SM Vaidya, about how they responded to the current situation. They adapted. They got into making parts which are not for aerospace purposes, but for something else, because they had the skill. So these are all, I think, very valuable, very important things to keep in mind. There was a good question from our other Ravi Kumar, GBV Ravi Kumar, and about what should people learn. I tell you, we had Mr. Palta, who I think Venki said graduated in 1969. I graduated in 1974, so I learned that Palta is 5 years older to me. But the important thing is, if either Dr. Palta or myself or any of us on the panels today, if we learned what we learned at that time and we stopped, we would have become obsolete 10 years ago, or maybe even 15 years ago. So it is not about what you learn so that somehow people can become wonderful, whatever, in the aerospace industry or some other industry. Do they have the foundation so they can learn more, they can adapt? GVV Ravi Kumar gave a great overview presentation on what Industry 4.0 is all about. I bet, I don't know when Ravi graduated, but I can take a bet that there was this idea of Industry 4.0 did not even exist when he was working on his PhD. So, this is the reality of our life. Things are going to be changing. It's not going to be like 2021, suddenly everything will be stabilized and we are going to look like this for the next 10 years. Things will change. That is the nature of the world. And if we want, either as leaders in the industry or as new entrants into the industry, if we want to be relevant, be prepared to learn, be prepared to watch what is going on around us, and then adapt. Now, talking about adapting, I want to bring out one other point which was not mentioned anywhere. We were all talking about Atmanirbhar and how I want to do something in Tamil Nadu, somebody else wants to do something in Karnataka, whatever that is. But the reality is, aerospace is a global business. We may say, I want to make LCA in India, but go take a look at all the components that are used in the LCA. I think even today, more than 50% are coming from somewhere else. It may look like it's an Indian aircraft. It is not an Indian aircraft. It depends on, yes, it was designed in India, but you go open the aircraft and see what's inside. It is not Atmanirbhar by any means. So my point is, we are going to be competing. Whoever decides to get into this business, we are going to be competing with the rest of the world. And don't think we are competing only with the US and European companies. There are companies in Vietnam, there are companies in Philippines, in Malaysia, in Poland, who are all equally good when it comes to the cost structure. We must be thinking about how can we become more efficient, how can we demonstrate more quality, and don't think that we are the only ones who are doing 4.0. Other people are working on Industry 4.0 too. So this is like a continuous improvement process. So in some cases, we have to catch up, but even if we catch up, we cannot just sit there. We have to continue to improve and develop ourselves. So we have a lot of work to do. It's an exciting industry, by any stretch, any measure that you can come up with, but it is not an easy industry. It takes a certain level of dedication, certain level of involvement to say that, yes, I want to be part of this game and I will put in all my strength and all my energies to become best at this game. So I think that's my message to you. It's not so much of a summary. Again, thanks to all the wonderful, speakers and panelists. There was a huge amount of, very, very interesting, valuable information. So I don't think I'm qualified to come back and repeat all that. It's not necessary. I think you all heard what that was. I just wanted to take a few minutes to share my thoughts. Thank you again for participating. We look forward to more sessions like this, organized by SAEINDIA, and whether it's IDOT or any other partner that we will work with. We hope we will have more conversations like this. Thank you very much. Back to you, Venki.
Thank you, Dr. Bala. I think that was more than a summary and also the highlights, the future forward. Thank you so much, Ravi Shankar Mysore, as well. It would only be appropriate to have a representative of IDAT for a couple of minutes to say, and then we will say word of thanks and close it. Mr. Shekhar, would you like to talk or would you like to nominate anybody else? 2 minutes. because it's a SA India and IDAT program.
Yeah, I would like to ask Dr. Christopher, being the chairman of IDAT, to say a few words.
Dr. Christopher, please.
It is indeed a pleasure for me to be a part of this association between SAE and ourselves, and it's really a learning for our probably our members. And I'm sure, similar to that, some of your members also learned a lot. The last summary or the validatory is much more interesting and comprehensive in terms of intuitively telling what the challenges and what we should do. We cannot sit idle, and even I mean, of course, I'm even younger than probably the others, but even then we need to know that we have to learn all the time. That's the reason even after retirement I took the profession of a professor, so that along with the students and youngsters you learn a lot. Thank you very much once again. I'm sure we will have a many more such an association and try and do functions like this. Thank you very much.
Thank you, sir. I'm going to take exactly 2 more minutes. We'll finish at 6:15. So, ladies and gentlemen, SAE India is organizing a couple of virtual programs. The pandemic also has given us opportunity to run more programs virtually. Since March 24th last year, we have conducted about 170 webinars, several training programs, we call it as PDP, and 4 major conferences. And as a sequel to our aerospace conference, technical conference, which is AeroCon, February 1st, we are conducting in alignment with Aero Show, again virtual. We were debating whether it is in person or virtual, and then finally we chose virtual this time because the 5th edition, Flying Out of Turbulence, Reimagining Defense Aerospace Industry, focusing on the defense industry. This is again from 2 o'clock till 5:30, 6:30 on February 1st. Please do attend. You will get all this information and leads in one place, that is saeindia.org. And I'm going to stop there. Thank you so much, ADAT. Thank you so much, members, speakers, and all the eminent personalities. Have a good evening. Have a good weekend. Thank you so much.
Thank you.
Thank you. Thanks a lot.
Thank you. Thanks a lot. Wonderful.
Thank you. So, Dr. Ravi, thanks.
Thank you. Thanks a lot.
Thank you. Thank you all. Yeah. Thank you, Inky. Thank you so much.
Yeah, thanks a lot.
Yeah, good job, guys. Good show today.
Thank you. Good job.